Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about how to build an RTS inspired resource management city building system of sorts. So, we're going to go through the process of building out our basic building system, building out our basic RTS camera. We're going to talk about how to manage resources and how to set all of that up, how to get resource gathering to work in a generic way. We're also going to talk about how to create food and how to build out a small economy system so that we have gold and have the ability to sell our gathered resources. And finally, we talk about happiness and how to build a happiness system so that the player has to actually make their people happy or they'll want to leave the castle. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so first we need to set up our scene. So our scene is going to be pretty simple. We're basically just going to create a 3D scene. We're going to right click, add in a child node. Let's add in a static body. We're going to right click that, add in another child node, and let's add in a mesh. Now I've had bad experience with CSG meshes crashing on me, so I'm just going to add in a mesh instance. And I will click on my inspector. I will go to my mesh and I'm going to add in a new cube mesh. We're going to make this nice and large. So however big you want your world to be, now's the time to kind of set it. Although, of course, you can always change it later, but I'll just set it to be something about this big, give or take. And then for a static body to work, you need to actually have a collision box. Now, if you want, if you just right click your mesh here and you add in a child node and you add in a collision shape here, and then you add in a shape and you add in a box shape, you'll notice that it automatically jumps to the extents of my box I built. The reason for that is because the transform of this mesh instance becomes what this collision shapes transform is. So it automatically scales it to the correct size. So now I can just drag this guy up and he is the correct size for what I'm looking for. Now I'm going to also want to pull this guy down just a little bit. So we'll just kind of switch to our move tool and we'll just drag this down just a tiny bit. And that's going to make it so that we can see our grid lines through our floor here. Now, once we have this, we need some way to be able to see all of our environment, right? So we're going to need a camera. So we'll right click our spatial node, we'll add in child node, we'll add in a camera. And our camera is going to be about here-ish, if you look. But we also want to angle it down. So if we just switch over to our rotation and we rotate this guy down something like 20 degrees or so, and it's up to you on what percentage you want it to be rotated. In my case, I'll just do it about here, I guess. That seems fine. Or maybe I could go a bit more if I want to be a bit more aggressive. So maybe we can go a tiny bit more and we'll go with something like 80 degrees. We'll say minus 80. That's way too much. So we'll go with minus 60. And that seems fine. So I'll just set it to that and that's fine. So if we take a look at our camera, that's what it's going to look like, which you really can't see much, but that's okay. If we right click, add in a spatial, add in a child node and add in a mesh, we'll just drop in a small mesh instance and we'll make it a capsule like so. And we'll pull this guy up. We're just going to assume that this is about the average size of an actor or of a citizen in our game. So if we take a look at our camera, that's about how big they'll be. I think that that's fine. I think that's acceptable. So we'll stick with what we have. Now, if we hit play, it's going to say, hey, no main scene has been defined. You can change it later. And we need to select our current, but we can't select our current. So why is that? Well, that's because we haven't saved our scene. So let's hit Control S and let's just save it as test scene.tscn. I try to save my first scene as a test scene so that way I have somewhere I can kind of sandbox all my work and I can just kind of test and see how things work. Now, if we hit play and we hit select current, you'll see that we have a camera. which is very exciting. But we can't really move our camera. So we can't go outside of this bounds if we were building a level. So how can we set it up so that we can go over to the corner of our screen and actually move our camera? Well, to do that, we need to build a camera script so that we can do that. So if we go to our camera, we right click and attach a script, and we'll just call it camera.gd. And what we're going to do is on process, we're going to actually check our mouse position. And then we're going to check to see if it's within a threshold size. And if it is within that threshold size, then we know we can move our camera. So what we'll do is first we'll get our viewport size. And the reason why is because if somebody makes the viewport bigger or smaller, then our threshold needs to change based off of that. Because if we don't, and they adjust the size of our window, what's going to happen is they'll be able to put their mouse in a small portion of the window. So for instance, if we were to change the size of this and our thresholds are the edge of this object, if we drag this down like so, our threshold would still be right here, not down here, because we don't have our viewport size. So that's the reason why we need to pull that. So we'll pull that by saying var viewport size is equal to get viewport dot size. And then we have to get our mouse position. So we can do that just by grabbing our viewport and getting its mouse position. So we'll say var mouse pos is equal to get viewport dot mouse position. Then we'll hit enter, and we're going to need to start building out our thresholds. Now we have an X and a Y in our threshold. Remember, this is a 2D world in terms of the camera's sense. So we only need to check our X and our Y. So our Y, which is up and down, and our X, which is left to right. So we can just check to see if it's within a threshold, and if it is, then we're good to go. So we can just say if mouse pos dot X is greater than our threshold, which in our case, I'll just set it something like 10 for right now. And if so, then we can actually set our translation dot X minus equals our step value, which will be something like 1. Now, how do I know this? Well, you can see if mouse X is less than the threshold, then I know that it's going to go minus, which means else if mouse position dot X is greater than our viewport size dot X minus our threshold, which in our case is 10, then we can just set our translation dot X plus equals 1. And then we could basically just do the exact same thing, but for Y. So we'll just copy this, paste it, and then say dot Y, dot Y, dot Y, dot Y, and dot Y. And that should pretty much do it. So now if we hit play, we go to the edge, you'll see that we can now move our screen. But it looks like our stuff got messed up. We are zooming instead. So this needs to say our translation dot Z instead of translation dot Y. And the reason why is because if you look at your object in 3D and you look at your camera, you'll see that we have Z and X, not Y. So in 2D coordinates, up and down and left and right is Y and X respectively. However, since we're trying to move this object left and right and forward and backwards, we need to translate that Y motion, which is up and down, to forward and backwards, if that makes sense. So now we can just hit play, and you'll see if I go forward, we go down, we go backwards, we go right, and left, we go left. And that's how you make a really simple movement system for your camera. Hey guys, Editor Mitch here. So I'm just jumping in really quick to expand on our camera system. One of the big things that I don't really talk about in the tutorial as it is recorded is how to actually do like rotation or how to do zooming. And I feel like that's something that's going to be useful, especially if you're doing a castle or something like that, and you need to be able to see over walls and stuff like that. So we need to capture our middle mouse button input to actually cause our camera to rotate. Now, I've already done that. If we go up to project settings, we go to input map. I actually have a middle mouse button device middle mouse button. Now, if you don't know how to do that, just type middle mouse button here and then come in here, hit the plus icon, go to mouse, and then choose middle button, and that will basically do it. And I also did the same thing for wheel up and wheel down. So I created mouse wheel up and mouse wheel down for our zooming. And you once again can go to mouse button and wheel up and wheel down respectively. Now, once we have that, it's actually way simpler than you might imagine. So first, if we scroll down here, you'll see that I have my camera right here. You'll see that I have my camera right here. Now, if we want to zoom in and zoom out, we need to make some small adjustments to how our camera is set up. So first, we need to tuck this guy underneath a spatial node, because when you're moving your camera in and out, so you're zooming in and zooming out, you need an object for reference for you to zoom in and out too. And most of the time people use a 3D point in space like a spatial node. And same thing with rotating. You need to rotate your object around some kind of object, or else it's just not going to work very well. So in our case, we're just going to use a spatial node to do that. So I'm going to scroll up to the top and I'll minimize my control in my area 2D, and I will add in a spatial node. I'm going to put my camera underneath my spatial node, and I am going to detach my camera script and reattach it to my spatial node. I'm going to rename that spatial node camera rig, and I will leave it at that. To get us to rotate, all we have to do is just type if input dot is action just released, and then we can choose our middle mouse button like that. And then we could just say rotation degrees plus equals vector 3, 0, 90, 0. And that'll allow us to rotate by 90 degrees. And if we want to zoom in, all we have to do is say if input dot is action just released like that. And we can do middle mouse wheel up like that. And then we can just grab our camera reference dot translation minus equal $ camera dot global transform dot basis dot z multiplied by some kind of value. In my case, I'm going to set it to 2. Now, what the transform basis z does is it gets the local z axes of that object, and it allows you to zoom in and out. So it allows you to go forward, if that makes sense, or backwards, if that makes sense. And then we can basically just copy this bit of code here. And thankfully, this part's pretty easy. So mouse wheel down, and then just plus our camera global transform. And then if we hit play, you'll see if we middle mouse button click, we can rotate. And if we zoom in and zoom out, we can zoom in and zoom out. So it's really that simple. Now we may want to have some kind of threshold here. So we should probably have some kind of check to just say, hey, is distance to an object too close or too far away? And if it is, then don't zoom in or zoom out. So we can actually just do that by hitting if my $camera dot translation dot distance to our translation. And remember, this is going to be the translation of our actual camera rig. Because remember, we're moving everything in relation to this object. So when we zoom in, we're getting closer to this object. So we can check that distance and we can say, hey, if it's greater than 10, then allow us to do our thing. And then we can also do the exact same thing. So if I just copy this guy, I tab this in, I hit enter and I paste like so. And I just flip this guy to something like this, the opposite way. So it's less than a value. In my case, I'll set it to something like 50. Then if we hit play, you'll notice that when I zoom out, I can't zoom out anymore. If I zoom in, I can no longer zoom into the ground. Well, actually, I can zoom into the ground. So let's take a look real quick. So the reason why we're having that bug is because this needs to be global underscore translation. Now, the reason why is because we're not checking our distance based off of the actual global translation of an object. We're doing it off of the local translation. So when the object moves, the actual camera rig over here, it really messes with everything. So we just need to make sure that we keep that in mind and we do everything off of our global transform. And now if we click and we zoom in, it should stop us from zooming in, and we can't zoom in anymore. No matter where we move, we still cannot zoom in anymore. If we zoom out, you'll see that we can't zoom out anymore as well. So that's just something to keep in mind. Now, something else that we have as a small bug is if we rotate this by 90 degrees and we go to the right, you'll notice that we're moving to the right. And if we go up and down, we're moving left and right. So that's definitely a bug. So how we can fix it is basically coming up here, changing these guys to global translation. So global underscore translation, get rid of that .x, and much like how we're grabbing our global transform basis down here, we basically just do that here. So global underscore transform dot basis dot, and in our case, we're moving on the x-axis, so we'll just do dot x, and then we basically can just copy this section here, copy, paste it, grab this guy, copy, and paste it. And then we can come here to where our global translation Z is and basically copy this guy, paste it, and paste it. Grab this guy, copy, paste, and then just change these guys to Z like that. And that should work. So if we go up, we go up, we go down, we go down, we go left, we go left, we go right, we go right. If we rotate, we go up, we go up, we go down, we go right, we go left, and we're good to go. There we go. Easy enough. And that's how we can make sure everything kind of just works together. But I just want to show you guys how to create this little camera controller so that way you guys had something a little bit more than just being able to, stay in one basic direction. So that's all I have for you guys. So let's get back to the video. Now, once we have that, we can actually build out our spawning system. So the first thing we have to do to build our spawning system is we need to have some kind of game manager. You should always have a game manager. Game managers make everything better. They basically manage the entire state of your game. They house all your resources. They house all of your population. They basically handle everything that's game related is what that's for. It's to basically house all the game states and anything that's global that you might need. So to add a game manager, all we have to do is come over to our RES, click new script, and type game manager, and then hit enter. And if we double click this guy, you can see we have ourselves basically a game manager. Well, kind of. It doesn't really have anything in it yet, but it at least exists, which is good. Now, if we want it to actually do stuff, we can set up a state machine for our game. Now, in our case, we're not really going to use our game manager in the sense of it's going to have a state machine and then that's going to handle all of the things, but we are going to use it to keep track of the global game state. And that is really useful, especially when you're building a game that, you know, if you hit escape, you want to pause, or if you have states that you want to switch between when the player is doing actions. For instance, if you want a play state, a building state, and a destroying state, right? In this case, that's what we're going to be doing. But it's useful for keeping track of that kind of stuff. So in our case, we'll just type enum state, and we'll pass in what kind of states we have. So our first state's going to be play, and then we have building, and then we have destroying. And we need a way to house that state. We need to know what state we're in. So we'll just say var current state, and we're going to make that equal to state.play. And that'll allow us to know what our current state is. Now you'll see it says I have unexpected indentation, so we'll fix that real quick. And that will basically allow us to keep track of what state we're currently in. Now, we also need to keep track of all of our resources. Now, we could have a resource manager, or we could have a scene manager or something like that to keep track of that. But really, we can just throw it in our game manager, and that's totally fine. So I'll just throw it in here and say var wood : equals 30. And what : equals means is it's saying, hey, assign this value and make it that type. So it's this basically means the same as if I said var stone and I said :int equals 20, right? So this is the same as this. It's just shorthand. So we can just kind of do this, and that is the exact same as that other line. And now all we have left is our other 3 resources. So we have stone, wood, gold, we have iron, and we have food. So we have gold, we have iron, and we have food. We're going to set our food to 0. We're going to set our gold to 100, and we'll set our food to 20. That's fine. And now, once we have this, all we have to do is set up our build system. So to do that, we can just right click on our RES, we can hit new script, and we can just type build manager. And I spelled manager very wrong. Let me rename that. AGER. There we go. And we can open that up. And to get started with our building, we need to load in some packed scenes. Now, in my case, I already have some assets built right here, which, as I said before, I have a link to in the description below that you guys can download this starter scene and use it, you know, for your project. Now, you can see if I look at some of these objects, you can see that they are a static body with a node here, a mesh right here, a collision shape, an area, and a collision shape. Okay. And you can see that they have a connection here, but this connection doesn't technically do anything. I don't know why they're in here, but I will delete them as I see them, and we'll have to reconnect them later anyway. So don't worry about those guys. We'll burn that bridge when we get there. So that's what we basically need for our objects. Now you can see that they are very modern, and unfortunately I don't really have any legacy castle granaries or houses or anything like that. So we'll just have to use these modern assets by Kenny Assets and just use them for testing purposes. We'll switch them out someday when we actually build out proper assets. Now, to build one of these guys, all we really need to do is, if we go to our home and we scroll down here to house type 20, we'll double click on this and we'll just click new inherited. We're going to right click our house type and we'll rename this as castle keep. We're going to take this mesh here. We'll scale it up by 10. And hopefully that'll be the correct size. If not, we'll probably have to come back and clean this up. We'll just hit Control S. We'll go into Assets. We'll save this as Castle Keep. Then we can right click our Castle Keep, change its type to Static Body. And then you'll see that it has that little exclamation point saying, hey, this node has no shape, so it can't collide with anything. So we need to make it so that we can collide with stuff. So all we have to do is come down here, click on our mesh, go over to mesh and create a single convex collision and just click on that. And you'll see it's going to create a nice simple collision shape for our object. And then we can basically just select that, duplicate it, pull this guy up, right click our castle, keep, add in a child node and add in an area, and then drag our collision shape into our area. And there you go. You have yourself basically your stuff set up. Now, in my case, I also need to add in somewhere to spawn my citizens when I get to that point. So we'll just right click, add a child node and add in a position 3D. And we'll just drag this guy out here and name this as spawn point. And we'll get to that point when we get there, but I just want to set that up so that way it is set up properly for us. Now we can just hit Control S and save it, and we can close it. Now, all of that was just to say that we already have our stuff, so we don't have to worry about it. But I thought I'd go through that so you guys could see how that works. And of course, we're going to have to go through and reconfigure all this later. So, it'll be fun when we get there. Now, to do our building manager, we need to know what state our game manager's in. So if we go into our process and we say if game, and you'll see that nothing comes up. And that's because our game manager is not static. It needs to be static because game managers sit outside of your project. They're not actually contained inside of your scene. So they need to be static so that other people can access them at will. And same thing with our building manager as well. It kind of needs to sit outside because people are going to use this script to build something. So we'll just come up to project settings. We'll go into auto load. We'll go to path and we'll select our game manager and then we'll click add. And we'll do the same thing with our building manager. And then we'll click add. And this is going to create what's called a static reference to this object. And that basically allows us to have a bunch of flexibility and allows us to keep this object between scene transitions. So if you wanted to say, oh, congratulations, you've defeated level 1. Now let's move to level 2. And you want to keep that score or those resources between those scene transitions, you can. Or if you don't, you can just reset them. So that's one of the really big advantages of a static reference to a class. So if we hit close, now if we come in here and we type if game manager dot current state equal to game manager dot state dot building, then we can build our stuff. And I'll just put a pass in here for right now. Now, when we want to build our stuff, we're going to need to do a lot of legwork. There's so much going on in here that it's going to be quite confusing. So let's talk a little bit about how we're going to manage this. So first, what we need to do is we need to raycast from our camera to our ground. So that way we can determine where we are in the world. Okay, so that way we can display our house as an object and it will follow your mouse. So we'll first build that. So let's come in here and let's build out that little bit of code. So we'll say var camera is equal to get viewport dot get camera. Okay, and that'll pull back our camera because we need a reference to our camera to raycast from it. And then to get the proper position of wherever our mouse is, we need to pull back our mouse position. So we'll say var from is equal to camera dot project ray origin like that. And we need to pass a screen point. And that is going to be our mouse position. So we'll say get viewport dot get mouse position. Okay. And what this is going to do is it's going to take our origin and it's going to translate that into 3D space. And now we need to do our to. So we'll say var, where are we projecting to? So we're projecting to our from plus our camera dot project ray normal. And then we'll pass in our mouse position. So we'll just say get viewport dot get mouse position. And then we'll multiply that by 1,000. And now what this is doing is it's saying, okay, wherever your mouse is, shoot a line from there in 3D space down to the ground, to wherever it can intersect with an object. Okay. And now we need to get that back. We need to say, okay, go do the raycast. Go grab the thing and give me back wherever my mouse is in 3D space. So to do that, all we have to do is we just have to say var cursor position is equal to plane vector3 dot up, comma, transform. And you'll see we only have a capital T. And the reason why is because this extends a node. So transform doesn't actually exist. So we need to extend a spatial node for this to work. And then we can come in here and say transform dot origin dot y dot intersects ray from comma 2. And what this means is we're literally getting back based off of a linear raycast. We're saying, hey, wherever this ray intersects from our array or origin point to our raycast position. And it's just getting back a linear transform and it's pulling back that cursor position, basically. And now all we have to do is we have to say print mouse position and we'll add in our cursor position and we'll cast that as a string so that way we can actually debug this. Now our current state is not equal to building because we didn't start off with that, and that's okay. We don't need to. And I got to close this, but we don't need to because what we're going to do is we'll add an interface element that will allow us to change our state. So don't worry, that will get handled. So before we can test this, we'll need to add that interface element. So we'll go to our test scene, we'll right click, we'll add in a child node, and let's add in a control node. And we'll go to 2D like so, and we will anchor this guy down at the bottom wide and we'll pull it up something like that. I don't exactly have an exact measurement, but we'll just put it right here. That's fine. And we'll right click and we'll add in a child node and we'll add in a button. We'll make the button about this big, give or take, and we'll just kind of throw it down here somewhere. And we'll just say wood cutters because we'll spawn our wood cutters first. So what we'll do is, since we need to change our game manager state, because currently we're in play state and nothing's going to work, since we need to change our state, we'll make it so that when we click on this, it changes our state. So we could just go to node and on button down and then hook it up to something and then have it change the state. But what we should do is we should set this to an interface manager of some kind. So let's right click our control node, attach a script, and just type interface manager. And then we can click on our button, go into our button, and then connect it to our control node. Now this says on button, button down. That's really bad form. We don't want that. We would want to say on woodcutters button down or on build woodcutter or something like that, right? So if we hit cancel, let's change the name of this to build woodcutter button like that. And then we could double click on our button, click on our control node and hit connect. And then there's our little function here. And then we'll just hit enter and we'll type game manager dot current state is equal to game manager dot state dot building. And that'll switch our state from playing to building. And now we could just click play and you'll see that we're not getting anything on our console, but once we click on our woodcutter, now we're getting our mouse position, which is perfect. That's exactly what we wanted. So now all we have to do is set up a nice spawning system. And I know that sounds super hard, but it's really not that bad. In our spawn build manager here, we need to get a reference to our object. So we'll just come up here and say var woodcutter's hut, and we'll make that a type packed scene like that. And then we can just hit equals resource loader dot load, and we can just pass in the path of our woodcutter hut. So if we come down here, you'll see that in our assets, we have our woodcutter.tscn. Like I said, I've already built these out for you guys so you guys can use it. So just drag this in here like this and drop it, and it'll pass in the location of our woodcutter hut like that. And there we go. So now we have a reference to our woodcutter hut. And while we're at it, we have all of these objects here. We might as well just build them out, right? So we'll just come in here. We'll copy, paste, 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 paste. I don't know how many we need, probably 7 or 8. So we'll just do that many. And we'll say woodcutter's hut. We'll say stonecutter's hut. We'll say granary. I believe we have a stockpile. We also have a ironworks. We also have a house. We have a wall, and I believe we have a corner wall as well. And then finally, I think we have an orchard, at least for right now. Now, this might be different later, but right now, these are all of the objects that I can think of that we have. And then we can just change these guys. So woodcutters to stone masons. And then our next one is a granary. So we'll say granary. The one after that is a stockpile. So we'll say stockpile. Then it's an ironworks. So I believe we called it... I actually don't think we have a ironworks, so we'll have to put a pin in that one for right now until we build it. We have a house, so we'll just come in here, house. This one is a wall, and I believe we have wall narrow. Whoops. Wall narrow, and then we have a corner wall, which is wall narrow corner, so we'll rename this. We'll just copy the name and we'll just paste it. And then we have an orchard, which is right here. So we'll just rename, copy, and we will paste it. And there we go. Now we have a bunch of objects that we'll be able to spawn eventually once we get our spawn system kind of settled. Now, once we have this, we need to know what object we're going to be spawning. So we'll create a variable for that. So we'll say var current spawnable, and we'll make that a type static body. And then once we have our current spawnable, now all we have to do is inform our build system what we're going to build. So to do that, we will create a function called spawn object. So we'll say func spawn object. We'll let that pass in an obj. Okay. And then we can just say if current spawnable does not equal null, then let's delete our current object. And what this will do is it's going to say, hey, if we already have an object that we're trying to spawn, make sure you delete that object before we instance another object, or else we'll have objects sitting on top of each other. And that's going to look really weird. It's going to be quite the bug. So we'll just check for that right here. Then what we can do is just instance our object. So we'll say current spawnable is equal to obj.instance. And then all we have to do is add this object to our tree. Because if you instance an object, it needs to be added to the current working tree, or Godot just says this object doesn't exist. It exists in memory, but it doesn't exist in the scene. So you need to say, hey, add this to Godot's working tree. That's this guy over here. So we have to put it somewhere in here. So what we can do is just say get tree dot root dot add child, and we can add our current spawnable. And then we can set our game manager state to building. So game manager dot current state is equal to game manager dot state dot building. And that'll set our state. And now all we have to do is set up our function to spawn our woodcutters. So we'll come up here and just say func spawn woodcutters, like that. And we can just say spawn obj, and we can pass in our woodcutter's hut. And that will allow us to spawn our woodcutter. Now, the reason why I did it this way versus having this code up here is because this allows us to have a lot more flexibility with our code. So for instance, if we wanted to spawn a stone cutters, what we could do is just say func spawn stone cutter, and we just have to say spawn object and then pass in our stone cutter's hut, and that's it. Whereas if we put this code up here, then each one of these guys would need to have repeated code. And that's a massive waste of code, especially if something breaks in one of these guys. Or if we say, hey, well, when we click on an object and we want to spawn it, but we also want to change your cursor to red, then I would need to change all of these guys, every single function, every single object we want to spawn. We would need to change that throughout the entire code base. Whereas if we have it in one function, we can just change it one place, and it simplifies everything. So now all we have to do is hook up our spawn woodcutter. So we can head over to our interface manager, come here, get rid of this line, and just say build manager dot spawn woodcutter. And that's it. That's all we have to do to spawn an object. And now, so we can go to our build manager, we can come up here, get rid of our print here, and then we can just make our current spawnable translation equal to our mouse position. So we can just go current spawnable dot translation is equal to a vector 3 cursor position dot x comma cursor position dot y comma cursor position dot z. Now I know you're wondering why I'm doing it this specific way, and I will explain it in a little bit, and it will make sense once I show you the reason why. But right now I'm going to have it like this. So if we hit play, we come down here, click on woodcutters, you'll see now we have an object following our mouse. Awesome. Now this is really useful and very, very, very great. But I want my stuff to kind of follow a grid. I don't really want to have exact, precise movement to where I'm placing my objects. If you guys want that, that's totally fine, and you can have it this way. But in my case, I want these guys to be stuck to a specific grid. So what I'm going to do is I'm going to add in a round to my object value here. And then I'm going to type round, and we'll round this object over here as well. And I'm not going to round my cursor Y. And the reason why is because that would force you to only be able to build in blocks going up, have 1 meter blocks. Now, if you want that feature, you can do that. In my case, I don't think it's necessary, but it's up to you guys. And then if we hit play and we come in here and we click on our woodcutters, now you'll see it snaps to perfect single block increments. And that's exactly what we wanted. Awesome. So now all we have to do is set up our spawning system. So when you click down, we want to spawn an object, right? So if we come in here and we type if input dot is action just released, and we type something like left mouse, it doesn't really show up. And that's because we don't actually have an action for your left mouse button click. So we need to add that. So let's come up to our project settings. Let's go to input map and let's type left mouse down. And then let's come in here and click on our little plus icon, click on our mouse button and make it the left mouse button right here. And we'll hit close. And now we can just hit quote left mouse button down. And when we release off of our left mouse button, then we'll spawn our object. So to do that, we can just create a duplicate of our object. So var obj is type equal to our current spawnable dot duplicate, because we're going to duplicate our object. So that way we can make duplicates, right? So that way if we want to, like if we're putting out walls or something, we don't really want to have to click on the button, then click, and then click on the button, then click, right? We want to be able to just kind of click and click and click and click, and then it will automatically spawn those guys. So we'll just do a duplicate here. And then much like our current spawnable, we're going to need to make it a child of something. So in our case, we're just going to make it a child of our root object for right now. And we'll, go from there. So we'll type get tree dot root dot add child, and we'll add our obj as the child. And then all we need to do is set our obj.translation equal to our current spawnable.translation, like that. And that should work. So now if we hit play, we come in here and we hit woodcutters, and then we click down, you'll see that we get multiple woodcutters. Awesome. That's exactly what we wanted. You'll also notice that if we click on our woodcutters button here, it lets us spawn our woodcutters, and you'll also notice that we can kind of spawn them inside of each other as well, which is a slight problem. So we're going to need to look at that as well. But at least we have our woodcutters working, which is great. So now let's first solve our interface clicking problem. So we'll hit X, and this is a common problem that I run into all of the time when I'm building a building system, or if I'm doing anything that has to do with mouse buttons on my Godot projects. And that's because basically your user interface doesn't block any type of spawning systems or anything like that. And since we're using mouse button down, it's not allowing you to stop the spawn, if that makes sense. It still assumes that you are over top of an object. So we're going to need to create some kind of variable that says, hey, can we spawn? Are we able to? So what we'll do is we'll come in here, and I'm just going to wrap this in an if, because in the future, I'm going to have quite a bit of extra code here. But if able to build, then do this. And then we need to create that able to build. So I will copy that. I'll scroll up and I'll say var able to build, and I'm going to make that a type Boolean. I will default that to true. So that way we have a Boolean and we are able to build something. Now, how do we determine if we are able to build something? Well, the simplest way to determine if we're able to build something and that we're not over a UI element is to cheat. And I know that that's awful to say, but it's true. The easiest way to do all of this is just to cheat it and to use an area to actually determine whether or not you're over top of a UI element. So what I mean by that is if we go to our 2D section here, we come into our control node, we right click and add in a child node, and we add in a panel. because I'm going to make this a little bit darker, and we'll just make that full rect so that way we can actually see what we're doing. I'll put that below my woodcutter so you can actually see it, and I don't like this not being centered, so we'll center it a tiny bit. There we go. And what we need to do is we need to create an area 2D that covers this whole panel. And we need to create an area 2D that follows the mouse. So first we'll create the area 2D that covers the panel. So we'll come in here, we'll right click, add a child node, and type in area 2D. And we'll put that guy in there. And then we'll right click, add a child node, and add in a collision shape 2D. Because an area 2D doesn't work if you don't have a collision shape. And then we can go into our inspector and we can add in a shape, and we'll just make it a new rectangular shape, and we'll just make it nice and large. So we'll say, hey, you cannot spawn if you are inside of this area. And to do that, we'll need to hook up this area 2D. So we'll come over here to our node, we'll add in an area entered, we'll hook it to our control, and we'll click connect. And then we'll do the same thing on area exit. We'll hook it to our control and click connect. So now we have both of our areas connected. And you'll see that I specifically chose area entered and area exited because we don't want it if a body enters or a body exits, even though we don't really have any bodies for it to enter or exit. We just don't need that signal to be connected. So we'll just do areas. Now, when we enter an area, we can just say build manager dot able to build, and we'll just set that equal to false. And then if you exit it, then we know that you can. So true, right? And now all we have to do is get our area to follow our mouse. And what we'll do is we'll come up to our spatial node, we'll right click, add in a child node, we'll add in an area 2D, just like we did before. And we'll right click it, add in another child node, and add in a collision shape 2D. And we'll make it, instead of a cube, we'll make it a circle. And then we need to make it follow the mouse. So that's pretty simple. What we'll do is we'll just right click it, attach a script. We will call it mouse area 2D. And we'll come into our process and basically just say position is equal to get global mouse position, just like that. And if we come in here, we go to project, debug, we come up here, we go to debug, we go to visible collision shapes. If we hit play, you'll see I have an area that now follows my mouse. And if I enter this object and I exit this object, you'll see that, well, nothing really happens. And that's because we're not really debugging any of this stuff. We don't have anything that says, hey, you can do the thing. But if we come into our woodcutters and we click, you'll notice that I'm not spawning any woodcutters. And that allows me to have that flexibility that I don't need to worry about spawning woodcutters when I'm in this area. So that really solves a nice problem that I always run into when I build these systems. So now that we have that, how can we set it up so that our objects don't intersect like that? Well, that's actually really simple. We need to build a script for our object. And what we'll do is we'll come into our woodcutter's hut right here. We'll right click it, we'll attach a script, and let's attach a script for our buildings. Now, we could build these as each separate individual buildings, but that's a lot of extra code that we don't necessarily need. So I'm just going to have one script for all of my building code, or at least a large sum of my building codes. And that's going to really reduce our complexity. So I'll just call this building object, like that. And then we'll just come in here, come into our area. We'll click on our node. We'll say area entered on our woodcutter. And then we'll come into our area and say on area exit and connect it to our woodcutter as well. Now we could do this one of two ways, and I'm kind of debating either way. I think it's going to be flexible. I think it'll be more flexible if we do it manually than if we do it with the connection system like this. So let's actually disconnect these guys. And let's come up to our ready and just say connect quote area underscore entered like that, comma, self, comma, on area entered. And then we could basically just copy this and paste it and say area exited. And then we can just say on area exited, which I already have that. So I guess I made a mistake here. So we'll say on area entered like that. And that'll make it a bit more flexible because it's going to do it on ready, which means we don't have to hook this up. It's just going to get hooked up. And that will solve a lot of trouble. Now, this actually isn't going to work because we're attempting to connect our own objects area entered, and that's not going to work. So we're going to have to hit $area.connect, and we'll do the same thing down here. That was my mistake. And now we can just basically say build system, build manager dot able to build, and we'll just set that to false. Then we can come down here and just say build manager dot able to build is equal to true. And now if we hit play and we drop a woodcutters in, and then we try to drop another woodcutters in, you'll notice that I can't spawn it until I'm outside of that object. You can see I can barely spawn it in here, and it looks like that's because I am coming in and out of my own areas. So then that allows me to spawn. So that's still a bug. Now, to fix this issue, what I'm thinking we can do is we could just come up here and say var objects, and we could basically just add that area to our object. So we could just come in here and say objects dot append, and we'll just pass in our area, and I'll make this a type array like that. And then we'll come down here, we'll make sure we append that object, and then when it moves out of the object, we'll remove. And we need to get a position, so we'll just say objects dot find, and we'll just pass in our area. And that should allow us to keep track of what objects are there, what objects are not. And instead of just setting our able to build to true, we can just come in here and check if objects dot size is equal to 0, or actually we should probably say less than or equal to 0. Then we can go ahead and just do our able to build is equal to true. So now in theory, that should work, hopefully. So we'll build a woodcutter and we'll attempt to build one here. That doesn't work, so we'll put one here. We'll try to go in the middle. We'll leave one, and it didn't quite work. You can see how when we leave this object, it didn't quite do what we want. So let's see if we print our objects like that. Let's see what happens. So we'll come in here. You'll see we print nothing. We place an object. We come in here. We leave. And we can print. So that's not ideal. It says that we have 2 objects in here. Okay, I think I figured out what's going on. So because this is just fetching out to whatever object gets removed, then it's setting our game manager ability to build set to true on the ones that are not colliding. And what I mean by that is if I do this and I do this, as soon as this guy over here gets an area removed, it's considered to say that we don't actually have anything in here. You can see it right here. So it sets our game manager able to build to true. And that's why we're having this problem. So what we have to do is we have to come up here and add in a var and say active object. Actually, we'll say active buildable object. We'll make that a Boolean. And we'll just say if active buildable object, then we'll do this bit of code here. And then same thing down here. We'll say if we're the active buildable object, then we'll do all of this code. And then when we go into our building manager, we could just set that down here as well. So you can see when we have our object and we have our translation here, we could just say current spawnable dot active, and I believe I said active buildable object. So we'll say active buildable object is equal to true. And when we build that object, we will set our active buildable object. So obj.active buildable object. We'll just copy this guy. We'll set that to false. And that should solve our problem, hopefully. So we do have an issue here. I'll just get rid of this additional parentheses here. And we'll refresh. And we'll put in our woodcutter. And then we'll come out. And then we'll come in. And we can no longer build, even though we're separating ourselves. So that's perfect. That's exactly what we want. Awesome. So now, once we have this, we need to set up our ability to spawn ourselves a woodcutter, right? Because we're spawning a woodcutter hut, so we need to be able to spawn a woodcutter. So that's where our building object comes in. We can actually set up a bunch of spawn code for it. So it's going to be really simple. We'll head up above our area entered, and we'll just type func run spawn. And that's going to allow us to have some kind of system to spawn our woodcutter. Now, since this is a building object, not a woodcutter object, right? It's actually just a generic building object. We may or may not want to spawn an actor, right? So let's export a variable so we have that ability to choose whether we want to spawn something or not. So we'll just export a var spawn actor, and we'll make that a type bool, and we'll default it to true. And then we also need an actor to spawn, so we'll export var actor, and we'll make that a packed scene. Okay. And what we can do is we can come into our run spawn and just say if spawn actor, then we can go var actor is equal to actor.instance like that. And then we can get tree.root.add child actor. And then we can just hit actor.translation global underscore translation is equal to, and if you don't have a spawn point, now's the time to add one. In my case, I already have one, and I put it right here at the beginning or at the entrance of my building here, this big old hut. And it's up to you on where you want to put it, but this is wherever your guy's going to spawn. So, you know, set it somewhere important. Now, if you don't have this and you've built your own assets, that's totally fine. Just create some kind of 3D point. In my case, I did a position 3D, and I just threw it right at the entrance. We'll go back to our script and just hit $spawn point dot global translation like that, and that will spawn our actor. Now, unfortunately, we actually don't have an actor to spawn, right? Because we never set up any kind of actor. So we need to build an actor. So let's come up, right click our RES, and let's create a new folder, and let's just call it scenes. And we'll right click, add in a new scene, and we'll name it woodcutter. And we'll hit enter. And then we'll go ahead and click on new 3D scene. We're going to right click, change the type, and we'll make it into a kinematic body. Now we'll right click this, rename it as woodcutter, and we will right click it and start building out our object. So first we need some kind of mesh so we can see it. So we'll add a child node and we'll add in a mesh, and we'll add in a mesh instance. Now in my case, I'm going to make it a cylinder capsule mesh like that. And I'm going to click on 3D so I can see it. And I'm going to rotate him so he's 90 degrees, and I'll pull him up like that. Now we need to have some kind of collision so he doesn't just phase through everything. So we'll add that as well. So we'll right click, add in a child node, and add in a collision shape, and we will make the shape into a capsule shape. And you'll see it's going to automatically size to our capsule, which is perfect. And then we'll drag this out of our woodcutter. And now we just need a way for this guy to move around. And we could build our own A-star navigation, and we might still do that. I'm kind of recording this portion of the tutorial ahead of time, so I'm not sure where I'm going to go fully in the future for the navigation side. But temporarily, we'll just right-click, add in a child node, and add in a navigation agent, like so. And that will allow us to have some form of pathfinding. Now we need to right-click our woodcutter and attach a script. So the script we're going to build is what's called a resource gatherer script. And we'll name it resource gatherer. Now, this script is going to be designed to be reusable. Much like our building object, we want to make it so that we can reuse this for any resource gatherer we want to use. So that way we're not held down to this is a woodcutter, this is a stoneworker. They all use the same logic. They go fetch the thing, they take it to the stockpile, and then they go back to fetch another thing, right? Very simple logic, but they all share that logic because it's all the same. So there's no reason to completely rip out each individual type of gatherer into their own scripts unless you want to add additional functionality to one. So for instance, the iron worker might not go and fetch the resource. They might go fetch the resource and then go back to their iron hut and then smelt the ore and then take the ore to the stockpile, right? That's options that you might want to put in. But for right now, let's make it simple and then we can make it more complicated. So first, our woodcutter needs to have some kind of state machine. So that means that he needs to have tasks. He needs to have something that he's doing. So to do that, much like we did with our game manager, we'll just add an enum. So we'll go enum task, and we'll set out some tasks. So what are some tasks that our resource gatherer needs to do? Well, first he needs to get resource. He also needs to search for research. He needs to deliver a resource. And he also needs to be able to walk, right? He needs to be able to walk to a location. So we'll say walking. Now, we probably should make these all actions instead of statements. So we can just say getting resource and delivering, and that'll give us a little bit more action. So he's delivering, or he's searching, or he's walking, or he's getting resources. And to me, that makes more sense than just say get resource, search, deliver, or walk. To me, it makes less sense logically in my brain. So I'm going to do it this way. And then we need to keep track of that state. So we'll say var current task. And that's going to house our task. Now, we also need to know where our home base is. So we'll say var hut for their home base. So we know where our home base is. So that way, if we ever have to go back to it, we know where it's at, providing that, of course, we set it. We also need to know how much resource we have. So we'll create a variable for that. So we'll say var held resource amount, and we'll just default that equal to 0. That way we just know that it's already set to 0 and we're good to go. We also need to set up a navigation agent because we already have our navigation agent here. We just need to set it up in our code. So we'll say var nav agent is type navigation agent, like that. And we'll make that equal to $ navigation agent. And you'll see we have a small error that says use on ready. So we can just do that. So on ready var navigation agent. That way we can assign it instead of using our ready. Now we're still going to need to use our ready, just not for that specific capability, but at least we can have that. Now we can set our current task. So let's set our current task equal to task dot searching. Because when you first spawn in, the first thing you're going to want to have your guy do is to search for resources, right? He wants to see where his resources are and then going to head over there, collect it, and then deliver it. So we'll say current task is equal to searching. Now, once we have that, we need to set up our actual state machine. So we'll come into here and we will set it up. So we'll say match current task, and we're going to match on our current task. Now, in our case, we have 4 tasks, so we'll set up 4 matches. So we'll say task dot getting resources, task dot searching, task dot delivering, and task dot, I believe the last one was walking, like that. Now, first, we need to set up whether or not our searching, because that's going to be the first state that we're in. So what we'll do is we'll come into searching and we'll say var resources is equal to, and we need to get some kind of reference to a resource. Now, we actually don't have any resources in our testing. If we take a look, it's pretty barren here. So we're going to need to create a resource. But we can do that on the back end, right? We can do that later. So what we'll do is come into our woodcutter script here, and we'll just say get tree dot get nodes in group, and we'll just pass in trees. Tree. That way we'll just grab whatever resource that is tree. And then we'll just go to the first one we find. So we'll just say if resources dot size is greater than 0, then we'll just set our target location to that. So navigation agent dot set target location to our resource object. So resources 0 dot global underscore translation, and that'll set their target location to that location. Okay. And then we need to set up them walking to that location, right? Because we're setting where they need to go. We're not setting that they need to walk there. Okay. So that means that we need to change our state to walk, right? We need to say, okay, we've found our thing. We need to head to that location. So we have to go to walking state, right? So current task is equal to task dot walking. And then we have to build out our walking task. So you can see here, we have a walking task right here. So we just need to set it to walk. So walking with a navigation agent is actually pretty simple. All we need to do is we need to get our target position, we need to get our direction, and we need to set our velocity to that direction, and then we need to move towards that direction. So to achieve that, we can just say var target position is equal to nav agent dot get next location. And then we could just create our direction. So var direction is equal to global translation dot direction to target position. And then we can just say var velocity is equal to direction multiplied by whatever speed value we want. Now we should probably abstract the speed value to something. So we'll just say walk speed, and we'll come up to the top and we'll just export that out. We'll hit export var walk speed, and we'll default that to 2. And then we just move and slide. So move and slide like that. And then we'll put in our velocity. And I know we're really far down the rabbit hole, right? We were just trying to spawn a dude, and now we're all the way down here. And I promise that we'll recurse back up and we'll settle this. But we just need to make sure that we know what's going on and we have stuff actually working. So once we are doing our walk, what happens if we get there? Well, we don't need to walk anymore, right? Because we already are there. So that means we need to check for that, right? So if we come up here, we could just hit if navigation agent dot is navigation finished. And If it is finished, then we've made it. We're good to go. So that means we can get our resource. So we can just set our current task equal to task dot getting resources. And then we can just return. And I'm going to put this back like that, and that should work for us. Now that we have this, that means we have to fill out our getting resources, right? Because we can't just have a state that's empty or else it's just going to completely break everything. So to gather resources, all we really need to do is have our guy walk up to the resource and then wait for whatever amount of time. And then say, yep, I've got my resources, and then deliver it, right? He wants to deliver it to the stockpile or to whatever it is that we need to deliver. So to wait, all we need to do is just say yield get tree dot create timer, and we'll just set that to 2.0, comma, and then we have to wait for some kind of signal to come back. And the timer has the timeout signal. And once that timeout signal gets reached, we'll just say held resource amount is equal to some value. And in our case, we'll just set it to 5. I think that's fine. And then once we're good, we could just say current task is equal to task.delivering. And we don't necessarily want this to happen every single frame, because if we do, our yield will run multiple times, right? So think of it like this. Every time this bit of code runs, it's going to create a timer, and then it's going to wait until the timeout happens. And then when the timeout happens, this bit of code is going to execute. So think of it kind of like I'm handing you a bunch of timers, right? So I hand you one timer every single frame. So you're holding on to all these timers. And then as the timers go off, you have to pull back that signal and say, okay, now run this code. Okay, now run this code. Now run this code. And you can see where I'm going with this. It suddenly becomes a gigantic performance drain on your game. So you need to counter code this. So what we'll do is we'll just say if run once, then we'll do this. And we'll set run once equal to false. And then once this is done, we'll just say run once is equal to true. It's a bit of counter coding, but it solves our problem very, very well. And then we could just copy our run once, come up to the top and just say var run once and make that equal to true. There we go. And that basically just cleans up our stuff a little bit. And we could really just get rid of all of this because we don't necessarily need it. And it's just adding to the confusion of our game. Now, once we're delivering, that means we have to code out our delivery section, right? So what is our delivery section going to do? Well, for now, I'm just going to say go back to the hut and deliver it to the hut, and then bam, we'll have resources. Normally, you would want to drop it off to a stockpile, but since we don't have a stockpile set up, I don't really want to go through the process of building that out just yet. So we'll just deliver it back to the hut. So what we'll do is just come into our delivery and say var navagent dot set target location to our hut dot global underscore translation. And then we'll just set our task to walking because we want to walk, right? So current task is equal to task.walking. Now this would normally work, but if we do this, what it's going to do is it's going to walk, and then once it gets here, it's going to attempt to gather resources. And unfortunately, we don't want it to do that, right? Because we don't need to gather resources. We already have our resources. So that's not going to work. So now we got to adjust this little bit of code here. So for us to adjust this, we just need to make sure that if we're holding on to some resources, that we know that we are delivering resources. So we can just say if held resource amount is equal 0, then we know we're gathering resources. Else, we know if we have a held resource amount that's greater than 0, then we know that we can drop off our resources. So we'll just say game manager dot wood plus equals our held resource amount. And then we can just set our held resource amount equal to 0. And then we can bring our current task back to searching. And oh boy, that was a lot of code. But if we've done everything correctly, this should work for at least getting our wood resources. We're going to need to abstract some of this code, or we're going to need to clean it up quite a bit to make it, usable for the rest of our project. But if we're lucky, this might just work. Now, we are setting our hut here. We are getting a global translation here. That means that we need to set it in our builder. So let's go to our building object, and let's come in here and set our actor dot hut equal to self. And that will basically set our actor's hut equal to this guy. And we're going to set this to our $spawn point global position, or our global translation. In this case, Godot 4 is still messing me up a little bit. But once we have that set, then our code should work. So let's double check it real quick and verify. So if we look at our stuff, we're doing hut.global translation. So that's not going to work. So we'll just pass in global translation. We'll just pass in hut for right now. And we might want to change this in the future, but for right now, we'll do that. And we will see how broken our code is. So let's hit play. Let's click on our woodcutter and click. And we've got nothing. So that's always a good sign. So the first thing that we should debug is our woodcutter's not spawning. That means that something's wrong with our building manager. So let's take a look at our building manager and see what's going on. So I'm going to delete this extra active buildable object. I think that's something I did incorrectly. And if we take a look at it, we're duplicating it. And I don't think we're running our building spawn code. So let's copy run spawn. Let's come in here and go obj.run spawn. And then let's try that and see what happens. So we come in here, woodcutter, click, and it looks like it attempted to spawn it, but we have a null instance here. That means that our object actor does not exist in Godot's house object. So let's, in our woodcutter's actor, so let's hit stop. Let's go to woodcutters and let's take a look. You'll see that our actor is empty. So let's drag our actor up there. So let's go to our scenes woodcutter and let's drag that in, hit play, and let's see what happens now. So we hit woodcutters, spawn, we have spawned our guy. Now you'll notice that, well, first I can move him, which is an interesting little feature, I guess. So we'll need to figure that out. That's not exactly ideal. But also you'll notice that our guy doesn't do anything, right? So if we spawn our guy in like that, you'll notice that he doesn't do anything. He just sits there. And the reason why that is because we don't have anything with the object trees. And also you'll notice that we can't navigate because we don't have a navigation mesh agent on this object here. So to create a navigation mesh instance, really all we have to do is right click, add in a child node and type nav and just add in a navigation mesh instance. And then we can just add in our navigation mesh and everything underneath this will get baked. So if we find our static body here, which is our test floor, if we drag this down into our navigation mesh instance and we just click bake, you'll see now we have a navigation mesh, which is good. Now all we got to do is add in trees to work with. So let's come in here, right click our navigation mesh instance, add in a child node. Let's add in a static body. And let's name this tree. Now let's right click it, add in a child node, and let's add in a mesh because we're going to need a mesh so we can see it. We're going to click on that and then go into cylindrical mesh like so. And we will scale it up quite a lot. So let's make it nice and large like that. And let's pull this guy up so that way, you know, we have a nice tall tree. And then we can right click our mesh instance, add in a child node, and add in a collision shape. And we'll go into our shape and add in a new cylinder shape like that. We'll drag it on top of our tree, and then we'll select our tree, go to node groups, and then let's put it onto the tree group, and then we'll click add. All right, now that we have that, we could just grab our tree. Let's move it over here and let's just kind of duplicate a few trees. So that way we have a few trees to choose from. And we'll just hit play, click on our woodcutter and click go and see what he does. Well, he's moving awfully slow, which is partly because I set that to 2. So let's speed him up a tiny bit. So let's go to our woodcutter. Let's go to our code and let's find where his movement speed is. I believe we had under woodcutter, I believe we had a walk speed of 2. So let's set it to something like, I don't know, 6. I think that might be a good number. Let's hit play and let's see what happens if we spawn in a woodcutter right here. You'll see he's headed and he's running. If we're lucky, he'll hit it. And we don't really know what he's doing, so it looks like he's broken, right? So let's set up a way to kind of help debug this. So let's come in here, let's hit enter, and let's add in a text object to help us out here. So we'll right click our woodcutter, add in a child node, and let's add in a label 3D, and we'll just add in a label 3D, and then let's take a look at this label. So we'll drag this guy up, we'll hit F, we'll go to our inspector, and we'll add in some text. So we'll add in some text and just say test, and A, it's really tiny, and B, it's not following our camera. So that's going to be a big problem. We will make it black because it should be black, especially with our white background. And we'll change our pixel size to something quite large. I think that might be a little on the large side. So we'll pull this down to something like maybe 1. And I think 1's probably still too big. So we'll go with 0.5. That's still probably too big. So we'll go with 0.3. And we'll just drag this guy up like that. And you'll see that it's not following our camera. So we'll make it follow our camera by going into flags and set billboard enabled, and it will always follow our camera. And that's really useful for debugging. So now all we have to do is go into our script and then just say $ label 3d.text is equal to our current task, and we'll need to cast that as a string. And there we go. So now when we hit play and we spawn in a woodcutter, we'll see he's on 3, which means he's walking. And he's still on 3, which leads me to believe that our navigation mesh has not been rebaked, and it hasn't. So let's go into our navigation mesh instance. Let's bake it like that. And you'll see that now we have our holes cut into it. Let's hit play. And let's click on our woodcutters and let's zoom down, click. He'll say 3, 0, 3. Awesome. So now he's delivered, quote unquote, delivered the goods. Now you'll notice he's just chilling on top of it, right? That's because our navigation mesh has not updated to reflect our build object. So to make it reflect, we need to actually set our build system to rebake our nav mesh. So we'll go to our script, we'll go over to our build manager, and inside of our build manager, we will tell our NavMesh to bake. So for us to do that, we need to get a reference to it. So the easiest way to get a reference is just to add it to a group. So we'll click on our navigation mesh instance. We'll click on node and we'll click on groups and we'll just say nav mesh. We'll hit enter and then we'll come in here and just say get underscore tree dot get nodes in group, and we'll grab our nav mesh. So we'll just copy this guy, we'll paste it, and we'll pull back our first instance dot bake underscore navigation underscore mesh, and we'll pass in a true like that. And what that's going to do is that's going to throw it onto another thread so we don't slow down our gameplay. Because one of the big problems that we're going to have if we have to rebake our navigation mesh is it's going to really slow down our game. And it's going to become really awful really fast. So we have to be cautious of that. So now, if we hit play and we click on woodcutters and we come down here and we spawn it. So what happened? Well, first I pushed him into the ground, but you'll notice that our navigation mesh never got rebaked, right? We'll still run into the same issue once he gets there. So if I kind of push him along like that, you'll see he just kind of hits the wall and then just kind of walks up here and just sits there. So why did that not get rebaked? Why did it not respect our actual building? Well, the reason why is because we actually need to make the spawned object a part of our navigation mesh. And to do that, we need to add it as a child. So if we come up here and copy this, we come up to the top and we just say var nav mesh is equal to that. And then we set our nav mesh. That should hopefully work. So now we can hit play. And let's see what that does. So if we spawn in a woodcutter, like so. He'll go up to it. Okay, so I figured out the issue. So what was going on is our spawn point was way too close to our object. So our navigation guy couldn't even get up to that point. So basically, he would run up to right here and just start colliding with a wall and then be like, I don't know what to do, and then throw up his hands and just kind of sit there. So now that I've moved this out a tiny bit, you guys probably won't run into this issue because I'll just update the resources. If we hit play, we come down here and run our little woodcutter. You'll see he'll come down here. He'll hit 0. He'll come up here and he will put a resource and then go back and start cutting more resources. And that's pretty much it. So now we need to A, keep track of our resources, right? B, we need to make him faster. And C, we need to make it so that we can't hit him when we are moving our mouse around. So the first one's going to be pretty easy. Not hitting him should be relatively simple. If we go into our wood cutter right here and we come down here, we just add a function called disable collision. Then we can just come in here and set our $collision shape dot disabled is equal to true, and that'll just disable it. And actually, we should probably just say set collision and just pass in a Boolean. And then we'll just set our disabled is equal to enabled, like that. And then that'll just let us set it throughout all of our build systems and all of our guys. So now we can go to our build manager and we can just come down here and say, okay, current spawnable is equal to object instance, current spawnable dot, and I believe we called it set collision. So we'll just set our collision to false or to true, I guess, because it's setting disabled. So maybe we should say set disabled. I think we'll change it to set disabled. I don't like set collision. Now that I'm thinking about it and I'm mulling it around in the old brain. So set disabled, and we'll just change this to disabled, and we'll change this to disabled as well. And we'll come down here and just set disabled, this. And then we'll copy this little bit here. We'll come down here and just come in here and just go obj.setDisabled to false. And that will enable our collision. And that basically solves our problem. So now when we hit play, we can come down here, drop a woodcutter hut, and we can't hit our guy anymore. And we still can't spawn our stuff. So that's good. Now we can spawn them like this, and that's a problem. So we're going to have to figure that out. I'm thinking what we'll do is we'll do the same thing that we did with our woodcutter here, where we're doing our area exit and area entered. We'll basically do the same thing. We'll just say, if we're colliding with anything, if any bodies enter, then we know to say no as well. But we'll burn that bridge later. Let's get some more of our actual stuff going. So we'll come into our test scene, and I'm going to clean that up because that's going to kill me. And what we need to do is we need to keep track of our resources, right? Now, if we look at our game manager, we have 5 resources here. Okay, we have our wood, stone, gold, iron, and food. So we need to keep track of that stuff in some kind of panel on the interface so we know how much resources we have. So if we go to 2D, you can see we have a nice little panel right here. So we could just come down here, come to our panel, right click on our control node, add in a child node, and let's add in a control node. And we'll just kind of make this about this big, give or take. The size really doesn't matter so much, just kind of however you want it to be put in here. And then we'll just right click, add in a child node, and let's add a VBox container. And we'll make that full rect, and we'll right click, add in a child node, and let's add in a label. Like that. And we'll set this to wood, colon. And then we'll duplicate that. So Control D, and we'll drag it right underneath our wood. And then we'll move this over to the right like this. And we'll set it to a value of something simple like 100. And if we want to align it, we can just come down here to our rect, and we can set our Y position to 0, and that will align it perfectly with the rest of our stuff. And we'll put wood, and we'll set this to wood value. And then we can just duplicate this 5 times. So we'll hit Control D, 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 1, 2, 3, 4, 5. We'll set this from wood to stone and stone value. And then we can set this to stone. And then we can do the same thing here with iron and iron value. And then we'll change this to iron, just like that. Then we can come in here and say food. And we'll set this to food and food value. And then we'll set this to gold and gold value. And then we'll click on gold, and we'll change this to gold. And there we go. Now we just need to set this up so it keeps track of what our game manager has. So if we go to our interface manager right here, and we come up to our process section right here, we can basically just say, hey, go update this every frame. And we could do this on an event system and say only update when somebody changes the value, but it's not going to hurt. It's not going to hurt that much for us just to set it every frame. So I'm just going to do that for sake of ease. But if you guys want to do that, of course, you guys are more than welcome to do that. So what we'll do is we'll just hit $ wood value dot text is equal to game manager dot wood, and we'll wrap that in a str like that. Now, this is great, but we can actually make this a bit faster and a bit easier. If we select this whole thing and we copy this and we hit paste, and we just get rid of this .text part. So just keep the .text. We get rid of the rest of it. We copy it. We hit paste, paste, and paste. I believe that's enough. 1, 2, 3, 4, 5. We can just come in here, drag our stone value in, drag our iron value in, drag our food value in, and drag our gold value in. And then we just have to hook up our bottom parts. So stone, iron, food, and gold. And there we go. And now if we hit play and we spawn in a woodcutter and we observe our wood, which is currently set to 30, when he comes back, we now have 35 wood. So awesome. Our system is actually working. Our resource gatherers are actually gathering resources, which is awesome. So now we need to abstract all of our code so we can set up our different spawnable objects. So if we come over to our building object here and we take a look at some of this code, we have all sorts of code that's specific to just our woodcutter. And since this is supposed to work with multiple things, we don't want it to just be one, this is how this works, right? We also need to set it up so that we can actually charge our player with the cost of what this item is. So to set up the cost, what we'll do is we'll come up here and we'll just say export var wood cost, and we'll make it a type int like that. And then we'll duplicate it a few times and we'll say wood, stone, iron, gold, and we'll add a cost that we didn't previously have, and that is population. And the reason why I'm adding population into the mix is because I was thinking about this, and I think adding population would be really cool. So you can only build if you have enough resources and enough people for you to actually maintain those buildings. My thought is that that's going to make it more dynamic and a little bit more interesting to play. Now, if we head down here, we have a section here where we are instancing our actor. We're putting our global transform, which is great. We have our area enter. We're doing our disabled. And I think that will work. And we'll be able to set up our building system with this. So we'll head over to our building manager. And when we do our build, we're going to want to check if we have enough resources, if we can actually afford it. So what we'll do is we'll create a function called can afford. So we'll come down here and just say func can afford, and we'll pass it an object, and we'll return a type Boolean. And then we can just check if we can afford this. So we'll say if game manager dot wood minus obj dot wood cost, if I remember correctly, that's what we called it right here, wood cost less than 0, then we can return false. And then we can basically just duplicate this over and over and over until we get all of our resources. So we'll just say false, 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 and I think that will work. So wood, stone, gold, and our iron. And then we could just say iron cost, gold cost, stone cost. And there we go. And then we can just say, if we get through all of this, then return true. And now we also need a way to charge our object. So we'll put a function here called charge object. We could do all of this above and we'll pass it on to obj. We could do all this above here, but that's going to really crowd a lot of our code, and it's just going to be easier to dump it out into a function, and it makes things a little bit easier. And we'll also drop back, and what we'll do is we'll just come in here and say game manager dot wood minus equals obj dot wood cost. And then we can just copy and paste this 4 times. like so. And we'll just say wood, iron, stone, and gold. And then we'll pass in our gold, we'll pass in our stone, we'll pass in our iron, and we have our wood cost set up. And that'll basically allow us to check if we can afford it and charge that amount. So now we can just head up here and check if we can actually do it. So if we're able to build and if we can afford it. So can afford, and we can pass in our OBJ, which is our current spawnable. And then we can just charge our stuff. So we can just say charge object OBJ. And then that should work. So now if we come in here and we click on our woodcutter and we click it, you'll see that it didn't really do anything. And the reason why it didn't do anything is because we never set up our cost of our wood cutting hut. So if we head over to our wood cutters and we click on it, so you'll see here we have a wood cost of 0. So if we set it to something like 5 and we hit play, now hopefully it will work. So if we click and we click, you'll see we now have 25 wood. So perfect. That's exactly what we wanted. So now that we have our cost going, we need to genericize our resource gathering. We've already genericized our actual building object, but we need to genericize our resource gathering. So if we head over to our resource gatherer, there's all sorts of stuff here that we need to do. So when we look at our searching section, you'll see that we are fetching any node in group tree. And that's not going to work because unfortunately we need to gather more resources than just trees, right? We need to be able to gather resources of any type. So what we'll do is we'll come up here and we'll just say export, and we're going to cast it as a type string like so, and we'll make it stone, comma, tree, comma, iron, because those are going to be the types that it's going to allow. And we'll just say var resource name to get. And I will close this real quick, give us a little bit more space here because I'm running out of space. And we'll come down here. And instead of saying get nodes in group tree, we'll just change this to resource name to get. And that will allow us to pull back any of those resources, whether it's a stone, tree, or iron. And then we also should set it up so that it gets back the closest resource instead of fetching just whichever one is lowest in the stack. It'll just fetch the closest one to it. That's going to be a better path for us to go with than to just grab whatever's on the stack. So we'll get our nodes in group like so, and we'll get back our resources. And then what we'll do is we'll just say var nearest resource object equal to resources 0. And then all we have to do is just loop through our resources. For I in resources, if, and check our distance. If I dot translation dot distance _2 translation is less than our nearest resource object translation dot distance 2, then we know that our object is closer, right? So we can just set that as our nearest resource. And that will set it as our nearest resource. And then we can just say this and then come in here and set our resource to our nearest resource object.global translation instead of doing it via our resources 0. And that'll pull back the most recent one or the closest one for us. And then we can just set our task as walking, and that'll get back the closest one that works for us. Now, we also want us to go to a stockpile if we're going to be delivering stuff. We don't want to deliver it to our actual hut. So instead of setting our target location to hut, let's set our target location to a stockpile, and we'll set it to our nearest stockpile. So we'll basically just grab this code here, all of this right here, copy it, paste it, and then just come in here and go, okay, var resources, we'll paste it like that and go get nodes in group and pull back our stockpile and pass back our stockpiles and copy this stockpiles 0 for I in stockpiles. Translation, that should work. Nearest, let's change this from nearest resource object to nearest stockpile object. And then we can set this copy like that, and there we go. And that's going to move us to using stockpiles instead of using the actual hut. And that way, it requires you to have both. You don't just need a hut, you can have the hut and the stockpile. Now, once we have this, now all we have to do is genericize our stuff. So we have some section, if I remember correctly, here in our getting resources, we're getting back a held resources amount. So we actually need a value for that. We can't just say held resources amount is equal to 5, because if you're doing iron, it could be 1, right? And if you're doing something like, stone, it could be 10, right? So we'll come up here and just export out that value. So export var resource generation amount is equal to, and we'll default that to 0, and I'll just change this to resource generation amount like this. And I think that might be it. Nope, we have one more, game manager.wood. That's unacceptable. We can't have it just give us wood, because we could be giving it iron or something like that. So what we'll do is we'll say if resource name to get is equal to iron, then we are going to do our iron stuff. So game manager dot iron plus equals held resource. If I can spell held to save my life, there we go. Else if is equal to wood, then we can do this. Now, we do have another option here. We don't necessarily need to do an if, else if, else if, else if. We could just pass in a match on resource name to get, and then we can just go quote iron colon, and we can just pass this guy in. It's slightly less in code and it looks a little bit better, so we'll do it this way now that I'm thinking about it. And we'll grab our game manager wood and change it to stone. And then the last one, which I believe, actually, I think that was it. So just these 3. So we'll grab these guys, delete them. And there we go. I think that will genericize it enough that we should be good. Yeah, I think that will work. Now we'll just put our stockpile in. So come to our test scene, go to 2D. We're going to need to add a button. So we're going to be adding a lot of buttons. So let's put these buttons underneath something. So let's go to where our button is right here. Let's right click our control node, add in a child node. Let's add in a tab container. And that'll basically house all of our stuff for our building system. So we'll bring this up and we'll just make it kind of large like this. And we'll right click it, add in a child node, and we're going to add in a HBox container. And you'll see that if I grab this tab container and I move it over, you can see what it's doing. So it's really cool because it actually allows us to just throw stuff underneath our tab container like this. And it actually, respects our stuff. It actually works really, really well. So now I can just come in here. I can name this tab something. So I can say, for instance, industry, like that. And then I can duplicate this and say, okay, this time it's going to be for food. And then I can duplicate it and say, now it's for living. Duplicate it. And I could say something like walls. And then I can duplicate it again and say, this is economy. And then I could duplicate it one more time and say market. And it's really that simple. And then we can align our tabs to the left, and now we have ourselves a very basic tab system that works well for us. So we can actually click through these and we'll be able to have different buttons. And the other nice thing is if we duplicate this, I can just grab this guy and say build stockpile, and I'll arrange that to the beginning because stockpile should always be at the beginning. And then we can just say stockpile, and that's it. And then all we have to do is hook up our signal and we're good to go. So we can actually come in here and go node signals, disconnect this, connect on button down to our control node, go like that, and then come up here and just say build manager dot spawn. And in our case, we actually don't have a spawn stockpile. So spawn stockpile like that. And then we can just go to our building manager right here, come down here and go bunk, spawn, stockpile like that. And we can just grab spawn object like so and go stockpile. And if we've done it correctly, this should just work. Now we do need to make a quick adjustment to our stockpile. If we double click on it, you'll see we don't have anything attached to it and it's not a part of any groups for us to work with. And if I remember correctly, we needed to make it a specific group. So if we look at our resource gatherer, it needs to be stockpile with a capital S. So let's copy it, click on our stockpile, add that, go to our inspector, go over here and drag on the building object.gd right onto it, and we should be good to go. Now, if you remember correctly, I believe we are setting, and I have to remember, I know this tutorial is kind of all over the place, but I believe we are setting our location where we want to deliver it within the spawn manager, within the builder. So let's take a look. Let's see, building object. So we have a spawn point dot global position right here, and that's what we're setting. And I have an entrance right here, so we can just change this to spawn point. I think that will work. You guys may or may not need to deal with that, but I'm just going to set it so that way it's set up. And then I'll hit play. And then you'll see that if I come down here, I spawn in a woodcutter and I have a crash, invalid, get index 0 on base array. That's because our resource came back as nothing, because I'm assuming our resource name to get is probably iron. Let's check real quick. Resources, nearest resources. It's just empty. So what we'll do is head over to our woodcutter and then let's click on it. And you'll see that we didn't set a resource name to get. So we'll get our trees. We're going to generate 5 and our walk speed is going to be 6. I think that's fine. And we can see if that works. So we'll hit play and we'll go into our woodcutters. We'll come down here, click, he'll spawn. We'll click and you'll see that we have set index disabled on null instance. So that's because our collision shape name is not the same across our stockpile and our actual object. So we can either make sure everything maintains the same, which I can check, see what my stonemasons is. So stonemason collision shape 2, collision shape. Orchard has collision shape. House is collision shape. So it looks like it's collision shape on everything but our woodcutter. So we'll just change this to collision shape. We'll set this to just collision shape, and let's try that and see if it works for us. So we will come down here, click on our woodcutter, click on our stockpile, we'll spawn that, and you'll see it crashes because our stockpile's spawn actor has not been set correctly, and that's because our stockpile doesn't spawn an actor. So if we head over to our stockpile.tscn, we come over here and click uncheck our spawn actor, and we change our wood cost to 15. I think that will work. We'll refresh it and let's try it one last time. So we'll click on our woodcutter, we'll click on our stockpile, and we'll see if he goes to the stockpile. Awesome. You'll see he goes to the stockpile, and then he goes to the next resource. Oh, you can see he's headed to me because he's taking my stockpile as the one I have in my hand as the actual stockpile. You can see he's actually going to my stockpile. So that's a bug. So how do we solve that? Well, we need to check to verify if our stockpile is not the one we have in our hand, if it's not active. So what we'll do is we'll come in here and we'll just check if it's been spawned. So we'll just say if I.spawned, then we can do that. And also we'll get our node and we'll fetch back a spawn point like that. I think it's got to be capital P. And there we go. And that's going to basically have them come to the entrance instead of trying to walk to the center of the object. So that will solve that small bug. Now we'll need to set a I spawned. So let's go to our building object and come up here and just create a variable for that. So I spawned like that, and we'll make that a type Boolean. And then we'll go to our building manager and set that here. So obj.spawned is equal to true, and we'll default that to false. And that should stop that from happening. So let's see what happens. So we'll drop a woodcutter in, and he's mad because I did it on the wrong thing. Well, that's my fault. So let's do this. Let's get rid of that. That's my fault, so we'll do that. We'll come into our delivering section, and we'll check if I.spawned, like so. We'll drop that in. And then we will also come in here and say .get _node, and we'll say spawn point. Like that. And that should work in theory. All the bugs today. So we'll spawn our woodcutter. We will spawn a stockpile. I'll also have a stockpile right here. See if he ignores me. And he does. So perfect. If I put it right next to him, see if he ignores me. And he does. So perfect. Awesome. Now that bug is fixed, we basically have the basis of a game started. Now we can just start filling this out because we have our stuff set up. So we can just come in here and build out our interface, right? So we can just come in here and control duplicate and build stone cutters. And we can change this to stone cutter like that. And we can come into our signal, right click disconnect, right click connect, come to our control node, click connect. And then we can basically just say build manager.spawn stone cutter, which I already had that function. And then we can go to our build manager, verify that spawn stone cutter works, and it should just spawn our object. And that's kind of the beauty of having everything as generic objects. It makes things a lot easier to expand. If we wanted to have a magic harvester, right? You could just say, okay, well, this now harvests magic and you're good to go. It's that easy. Now, to test spawning our stone worker, what we'll do is we'll come in here and we'll actually take one of our trees. We'll duplicate it like that. We'll pull it over here and we'll make it shorter and slightly fatter. And we'll just come in here and rename this to stone pile. And we'll come over here and get into our node groups, get rid of the tree, and then just type stone. And then we should be able to just have it work. So if we come up here, we click on our stockpile, we click on our stone cutter, we have a crash, non-existent function set disable, and static body. So that's because our current spawnable equals object dot instant. Our current spawnable set disabled is equal to true. That's probably because we never set up our stonemasons to have a script. You can see right here, it doesn't have one. So we just need to put that in. So let's grab it real quick. Like so, drag it in, cut and save. We'll do the same thing with our granary. We'll do the same thing with our house. We'll do the same thing with our orchard and with our stonemasons, with our wall narrow. We'll just drag that up. And that should about do it for right now. Now, when we go back to our stonemasons, if we select it, go to the inspector, you can see we have a wood cost. Let's make it 15. And we'll need to set a population cost eventually. We're going to have to set up a whole population system. So that's still on the list. But for right now, we'll just set it to 1. And I think that will work. We'll hit Control S. Stockpile will be set to 0. Stonemasons spawn actor. We don't have an actor, so we're going to need to actually create an actor. So let's come into our woodcutter. You see we have our woodcutter right here. So right click, duplicate, stone cutter, and then we can select on him, go in here and go stone cutter like that. His walk speed is going to be 2. His resource generated will be, I don't know, a good number of 10 maybe. And our resource name will be stone. And that will basically do it. Now we can just go into our stonemasons. Our stonemasons, we can select it and you can see we have an empty actor. So we can just come in here and put our stone cutter in there. And that should hopefully work. So now we can hit play and let's test it. So we'll put down a stockpile like that. We'll put down a stone cutter like that. He's going to walk really, really, really slow, but they will produce resources. Now, obviously this is way too slow, but that's okay. The point of it is just to show you that there can be differences. So now it's really as simple as, okay, I want to fill out my stuff. So let's come in here and let's click on our woodcutters. Let's set population of 1 because I forgot to do that real quick before I close it. We'll save it, we'll close, and then we have a test scene here left. So let's come into our test scene. Let's go in here and let's come down to our tab container. You can see we have our stockpile, woodcutters, stone cutter. So we'll need to duplicate that and do iron. Worker, and we'll just say iron. Forage like that. And we can just click on our little signal here, disconnect, on button down, go to our control, hit connect, and then we can just head back to our 2D. You can see we have our 3 major systems plus our stockpile, so we're pretty much done there. Now we can just head over to our food. So in our foods, we have a granary and we have an orchard. And you can see that if we click on our signals, we can just disconnect this method, come in here, connect our control node, go to our orchard, disconnect, connect it to our control node, and we're good to go. And that is all of our granary and our orchard. And we'll have to change the names as well. So granary and orchard. There we go. Now we can hide that. We can go to living. And in our living, we only really have one thing, which is build house. And we'll just put house like that. We'll go to our node. We'll disconnect, double click on our build, control, connect. And with our walls right now, for demonstration purposes, I'm just going to do the one that we originally have, which is our wall narrow. So we'll come in here, we'll right click, disconnect, change this to build wall narrow, and we'll come in here, right click, connect to our control node, go to our inspector, click on our build wall narrow and just say wall narrow like that. And then we just have to hook up all of our stuff. So if we look at our script here, we literally have everything here that we need. So we can just come in here, copy this, paste it, spawn, iron worker, granary, paste, spawn granary, paste, spawn our orchard, and build house, paste, spawn house, and finally spawn wall narrow like that. And now we can just go into our build manager and build those specific functions out. We can come in here, paste, 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 paste. And I believe we had spawn iron. Let me see. My memory is of a goldfish. So let's go to my interface manager, and it was spawn iron worker. So we'll go back to the building manager, spawn iron worker, go back to the interface manager, spawn granary. So we'll double click this, spawn granary, spawn orchard, spawn house. And we need one more, so we'll just copy this guy, paste, and go back to our interface manager, spawn wall narrow, like that. And then we can just say spawn object wall. I don't know if I actually had a wall. Let me see. I did. It's just called wall, which is fine. So we'll just call it wall for now. And then spawn house, we'll just call it house. Orchard, granary, iron. I don't know if we have an iron. We don't, but I can just kind of grab it. Did we not build an ironworks? I don't see one, so we'll have to do that later, but we'll copy this and do spawn ironworks, and that will do it. And that's how easy our system can be. And now we just need to make sure our stuff is correct. So we can go into our granary. We can click on our granary. Wood cost of a granary is 15, let's say. It's not going to spawn an actor because it doesn't need to. And we'll say the gold cost is 5 gold. It doesn't cost anything to man a granary, so we'll be good with 0 population cost. If we go to the house, well, the house is different, right? The house increases your population, right? So we're going to need to code that in, but we'll say it's 15 wood to build this, and we'll say 5 stone. That way it requires lots of resources. And then orchard, it's going to cost 15 wood and 1 population. It will spawn an actor, and we're going to have to build our actor for that. So we'll get to that when we can. So we'll save that. Then we can look at our stockpile, 15, no spawn actor, that's fine. Stonemasons, wood spawns actor, that's fine. Wall narrow, it's going to be 5 stone cost, and it does not spawn an actor, and 0 population cost. We should also check to make sure that our woodcutter's set up. Yep. So that's how easy it is to set everything up. So now all of this stuff in theory should work pretty well. Now, obviously there's lots of caveats to this. So we're going to need to do a bit of legwork to get this moving. So the first one is population cost that we never set up. So we'll do that now. So to do population, that's going to be handled by our game manager. Our game manager will house our population and things like that. We first need to keep track of our population. So say var population is an integer, and we'll make that equal to 0. And then we'll just duplicate this guy twice, and we'll say max population and available population. So ALV population. Now by default, I'm going to set max population to 4. And that's going to allow us to say, hey, we can have 4 people because they can sit in our keep. Or at least that's the theory. So one of our big requirements that we're trying to solve here is you need to have populace to give them jobs, and you need a place for them to spawn and allow you to see them. So that means we're going to need a keep. That means that we can't spawn them all at the same time, just because it would be not as much fun and not as emergent, I guess you could say, for gameplay. We would want to do that in a slow trickle. So that way you can't expand as fast as you want. You can only expand as fast as your castle is willing to expand. So that's why we have population. That's the total population of the map. The max population is the maximum population that your kingdom can have. And the available population is what's available for current use. That way we have lots of flexibility here. Now, since we're going to spawn stuff, we're going to need a citizen of some description. So I'm going to say var citizen, and I'm going to make that a packed scene. And that should be it for at least right now. Now, we don't actually have a citizen object, so we're going to have to build that. And we're going to need to do a lot of work to get this area built out for our population. Now, to start our population system, part of what makes a populace exist and actually want to come to your castle is their happiness. So we should probably build out a variable for that. So we'll say var happiness equals 1, and we'll just default it to 1 for right now. Now, we also need to create some kind of process to actually handle our happiness and to handle our spawning system. So first, we will check if we actually have enough population, and if it's greater than our max population. So we'll just say if population is less than max population, then that means that we can spawn some population guys, right? We can actually spawn our people. Now, we also want to make sure that we're happy, and happiness is greater than 0. And if they are, then we know we can spawn our population. Now, we don't want to spawn our population constantly, right? We don't want to say, okay, we have a happy population and we are less than our max. Let's just spawn our stuff. That's going to make our population spawn every single frame, and we don't necessarily want that. So we need to create a timer to slow that down quite a bit. So much like before, we can just have a var spawn ready. We'll make that a Boolean, and then we can come down here, check if our population is less than our max population, and spawn ready and do the things, right? And then we can say spawn ready is equal to false, then yield our get tree dot create timer, and we'll set our timer to something small like 3.0, and you can set it to whatever you want. It depends on how long you want our stuff to actually wait, and we'll just wait for that signal timeout, and then we'll just say spawn ready is equal to true. That way this will only run one time. It's going to create a timer, it's going to wait, and then it's going to say, okay, we can now create another timer. Basically is how it works. Now we're going to want to default this to true, so that way it actually, works for what we're trying to do, like that. And that will allow us to have a timer that only runs every 3 seconds and times out and things like that. And now all we have to do is we can set our population to plus equals 1. And this would be where we would spawn our population, where we would instance our guy, have them move forward and do all the things. Now, we also have an available population. So ALV population plus equals 1, like that. And that'll allow us to have an available population. Now, we do need to be able to spawn our characters. So that means we need to create a citizen. And we do need to have a place for them to go to. So that means we need to create some kind of object for them to walk to and spawn around, if that makes sense. So those are two things that we have to keep in the back of our mind while we're building this out. Also, we need to set up some kind of system to do the opposite. So if people are happy, they're going to come to our castle. If people are not happy, then they're going to leave our castle. So we'll just come down here and just do else if spawn ready and happiness is less than 0, then we will say spawn ready, much like we did before, is equal to false. And we'll grab our yield, get timer, like that. And then we can just say spawn ready is equal to true. And finally, if ALV population is greater than 0, then let's get rid of a citizen. Let's actually delete them. Now, right now, we don't have the ability, we don't have a citizen to delete, so we'll just say ALV population minus equals 1. And that will work. Now, once we're here, all we have to do is set up our population system within our build manager so that we can actually subtract people and add people when we build our stuff. So we can head over to our building manager and come up here. And you'll see we have a section here, if able to build, can afford current spawnable, right? We can also say, and game manager.alv population is greater than or equal to our current spawnable dot. If I remember correctly, we called it population cost. So let's take a look. Population cost. So we'll just grab that. And then we can just come down here and go game manager dot available population minus equals our obj dot population cost. And that'll basically make it so that way we can remove our available population from our actual game manager. So that way you have to make sure that the world keeps growing for you to gain population. Now, that also means that we need to set up a way for our players to actually increase their population, right? They can't just have just the 4 because that means that, you know, the game's not very fun, right? You won't be able to expand at all, and that would be a problem. So in the spirit of that, let's head over to our building object and add that capability in. So we have the ability to have a wood, stone, gold, and population cost, but we also should add in the ability to expand the population. So some buildings could spawn an actor and have it produce resources and also increase population if you want, or you could have one that just increases population. So it's really nice to have something that's flexible, and that's kind of the name of the game. So if we come in here, we can just export out a variable and just have it as increase pop cap. We'll make that a Boolean. We're going to default that to false, so that way it's not by default. That way we don't have that issue. And we can just say export var increase cap amount. And we'll make that an integer, and we'll default that to 5. I think 5 would be good for each building that you want to build. That way it's a little bit easier for us to increase and make our game expand our castle. Now, it's up to you guys on however you guys want to do this, of course. But for right now, this is what I'm going to do. And also NCREASE, increase cap amount. And then when we run our spawn, we can just come in here and go if increase population cap than game manager dot max population plus equals our increase cap amount. Now this is cool and it's going to work for us, which is great. We need to do two things. We, one, need to show the user that their population cap is increased, and two, we need an object that can increase population. So if we head over to our house, we click on our house, and we come here, just check the increase population cap and uncheck spawn actor because we don't need it to spawn an actor, and then we just save that. That'll give us some object that can increase our population. And for us to show the user, if we go to 2D and we go to our test scene, you'll see that we have wood, stone, iron, food, gold. That means that we also need some way to have a population. So if we come into our control node here, let's grab our VBox container and let's kind of make it smaller. And let's grab our wood, stone, iron, and gold, and let's drag our rect here down just a tiny bit. And by a tiny bit, I mean quite a bit. We're just going to do about 50 maybe to bring those down. And then that should allow us to snap all of these guys much closer to us. And that'll make things a little bit easier on us for the future. And then we could just grab our VBox container. We can duplicate it and just pull it over here like so. And get rid of most of these guys, like so. And we can say population, so pop, and then we'll just put pop here, like that. And then pop value. And what I'm going to do is we're going to need to change some of our code and make this nice and flexible, because we'll probably want to have 1 out of 20 or something like that, because that would make things a little bit easier. And then this one will just say ALV pop, and then we'll just paste that in like so. And we'll grab this, pull it back just a touch. We should probably do the same thing with this, so that way they line up. And then we can just have a value of something like 300, and we'll just do ALV pop value. Like that. And there we go. Now, when we do this, that should work. So it shows our population. Actually, this could be available population, max population. I don't think we need available population now that I'm thinking about it. So let's get rid of that and let's just do pop. I think that will work. We'll just drag this guy over like that. And I think that'll do it. And then we can just come into our interface manager here. We'll scroll up to the top and we'll just hit $ pop value like that dot text is equal to str. And we'll grab our game manager.alv population, and then we'll plus quote slash space plus game manager.max population. And it's going to be mad at us because this needs to be casted as a string like so. And that should do it. So now if we hit play, in theory, if we come over to our living, and you can see our population is going insane, so that's not a good sign. 184 is an awful lot, and we only allow them to have 4, so that's a problem. So let's take a look at our game manager, and let's see what's going on. So I'm not checking if it's equal to false. I'm just saying set it to false. So that's my fault. So let's see how that goes. So you'll see we have a population of 1, population of 2, 3, and 4. And if I build a house, we now allow us to have 9. So now we can continue growing our castle. And then if we come in here and we build a woodcutter, providing that we did things correctly, if we drag this over here, wherever our trees are, they're up here on the right. There we go. I'll just drop this guy in here. You'll see our population went to 8, 7, and it's mad because we don't have a stockpile. So we're going to need to check for this. So we can just come in here and go if stockpiles dot size is greater than 0, then do the rest of this like that. There we go. And that'll just solve that problem. But this should work. We may want an additional line here. It's up to us. But you'll see that now we have 2 guys, and we can actually just keep spawning these guys, which is a problem. So you can see that I can't spawn them now, but I was able to. So I'm curious, am I checking in my building manager, if I head over here, ALV minus equals population cost, ALV population, current spawnable. So if I come in here and I attempt to, okay, so it is working. It just seems to be that I was clicking at the correct time for us to not run into this issue. So, okay, that's fine. Great. So we have our population system kind of started, and we made it so that we can actually subtract our population, and we require a population, enough population to actually spawn our buildings. So that gives our players a lot better gameplay. They actually have the ability to expand their castle. Now, all we have to do is set up our entire population spawning system. Now, for that, we actually have a castle keep right here. And you'll remember that this we created when we started our project. So all we have to do is go into our test scene, go into our 3D, and let's set up a castle keep. Now you could make this a spawnable object. That's totally fine. In my case, I'm not going to, but you guys can. So if you just drag this guy in like so, and we're going to have to 0 him out. Oh, that's because our environment. So let's go onto our spatial node, drag this guy in. And let's 0 out our castle keep. There we go. And we'll need to add a spot for them to spawn our guys to. So we could just have them kind of spawn and just show up over here and just kind of hang out. But I think it would be fun to actually have some kind of object for them to kind of stand around. So let's right click our castle keep. Let's add in a child node. Let's add in a mesh. Let's add in a mesh instance and add in a cube mesh like that. We'll just kind of drag it out here. And then what I'll do is I'll right click, add in a child node, and add in a position 3D. Now we'll put this like so, and then we'll control duplicate, drag it like that, control duplicate, drag it like that, and drag it like that. And what I'm going to do is I'm going to limit the number of available population to these 4 spaces. That way you don't have your full population in existence, you just have the population that you're currently using. That way, when we add food later in the tutorial, you're not getting hit for a 9 population worth of food. You're only getting hit for, you know, whatever your used population amount is plus 4. To me, that makes it a little bit fairer for the player and easier to play. Now we'll take these positions, we'll come over to, so we'll take this position, we'll come over to our node and our groups, and we're just going to call this citizen spawn point. And I'll just copy that, click on these guys, paste, add, paste, add, paste, add. And then when we go over to our game manager, and we take a look at that real quick, inside of here, when we are ready, we can spawn our actual actors and have them walk to that location and kind of hang out around, you know, the campfire, right, while they're waiting to be used. So to do all of that, we actually need to build our actual citizen. So let's hit scene, new scene, and let's create a 3D scene. So you'll see we have a nice empty scene. Our citizen's going to be really simple, much like our gathering character. It's not going to have a lot to it. So we're going to right click, change its type to kinematic because it needs to move around. We're going to right click, add in a child node, and add in a CSG mesh, and then we will click inspector and add in a capsule mesh. We're going to rotate that guy by 90, drag it up like so. Right click our CSG mesh, add in a child node, and add in a collision shape. And then we're going to make that shape into a capsule shape, and that's going to automatically snap it to the size of our capsule. We'll drag that out to our kinematic body. We'll right click, add in another child node, add in a navigation agent like that. And then again, we'll add in a label 3D. That way we can keep track of our character's state if we need to. So we can come into text and just type test, and let's make it nice and larger than that. So 0.5 maybe, that's way too big. So 0.05 maybe. I think that that's reasonable. We'll make it black, and we will make it so that it follows our camera, so that way we can read it any way that we're looking. Now we can just double click on our spatial node, name it citizen, and right click, attach a script, and let's call it citizen.gd. That's totally fine. Now, for the most part, our citizen is going to be a very, very stripped down version of our resource gathering script. You remember how big this script is. Well, all we have to do is basically just build this, but build it simpler. So if we head to our citizen and we type enum task, and really all they can do is they can walk and they can sit, and that's all they can do. And all they really can do is just go to a position and sit down. So we need access to our navigation agent. So nav agent, navigation agent, and we're going to need to get a reference to that. So it's equal to $navigation agent, and we'll need to add an on ready for that, for it to pull that back. And then all we have to do is have a position to move to. So var fire pit position. And then we can just come in here and say nav agent dot set target location equal to our fire pit position dot, and I will make this a type position 3D, and then we could just say position dot translation like that. And we need to keep track of our task, right? So var current task, which I'm going to default to task dot walking. So that way we can actually walk. And that's pretty much all we need to do, at least in this section. And then we just have to build out our state machine. So we just say match current task, and then we just say task dot sitting, which will just pass, and then task dot walking. And if we're walking, we basically can just steal our resource gatherer section right here, because this is basically what we're going to do. So we'll just grab this bit of code here, we'll copy it, we'll go to our citizen, we'll paste it, and then we will get rid of all of this, and we'll just say current task is equal to task dot sitting. And outside of that, I think we're good. We do need to add a walk speed, so we'll do that real quick. So at export var walk speed, and we're going to default that to something like 3 or maybe 5. And we'll make that colon equals instead. And we'll just save that as citizen.tscn. And my Godot foreknowledge is coming back to bite me, so I did at export, but that works. So now we can go into our game manager and we can actually spawn this citizen. So this should be pretty simple. We have a var pack scene citizen, so we can just say citizen is equal to resource loader dot load, and we can just load our res :// and our citizen is located right here. So we can just basically drag that in and get rid of this and get rid of that. And that's my fault because I forgot it's going to pull back the RES with the quotes. And then all we have to do is just spawn our citizen and set its location. So to spawn our citizen, that's pretty simple. We can basically just come in here and say var citizen is equal to citizen.instance. And then of course we can just set this to the child of root. So get tree dot root dot add child and just add in our citizen like so. And that's going to make it exist in our working tree. And now we need to tell it where to go. But we don't really have access to all of our fire pit spaces. So we'll grab that up here. So we'll say var fire pit spaces, and we'll equal that. And we'll come down here and say fire pit spaces is equal to get tree dot get nodes in group. And I believe we called it citizen spawn point. So let's copy that and we will go back to our game manager like so. We'll paste that and that'll pull back all of those guys. And we'll make this a type array like that. That way we know it's an array. And something I'm going to do just because I already know that this will be a problem is we need to know if a fire pit space is occupied or not. So we'll add in a var occupied fire pit spaces, and we'll make that an array as well. And I will spell occupied correctly. And then we could just come down here and say, all right, we need to set our citizen's fire pit position. So citizen dot fire, I believe we called it fire pit position. So we can do that. So fire pit position is equal to, and we need to pull back some kind of fire pit. Now, the nice thing is we already have all of our fire pit spaces right here. So we can just say fire pit spaces, and we could just pull back our first index. And then because it's occupied, we need to add it to our occupied fire pits. So occupied fire pit spaces is equal to fire dot append fire pit spaces, and we'll just pass in our 0. And then we need to remove it from our actual fire pit. So fire pit spaces dot pop front. And actually, I can just grab this, and I could probably just put this like this. I think that should work. So now we're adding it to our occupied fire pit spaces. We're adding it to here, and that should work. Now, something that we want to be careful of is we don't want to be able to spawn anything. Even if we have the available population, we don't want to spawn anything if we don't have any fire pit spaces. So we'll have to come in here and add that capability. So we'll come up here and just say, and if fire pit spaces dot size is greater than 0. Because if it's not, then we don't want to spawn our stuff. That's going to cause problems. It's going to break everything. And then that will spawn our guy. That will set our occupied fire pit space. It should force him to move to that location, and we should be good to go. Now, if we come in here and we are eliminating stuff, then that means we have to eliminate our child, right? Our child object. Now, of course, we're not at this point yet. We're not building out our full happy system, but we can kind of build this out as we need to. So what I'll do is we'll say if our available population is greater than or equal to or greater than 0, our available population goes to -1. Instead of doing -1, let's dump this out as a function. And the reason why is because in the future, or not even really in the future, but when you want to spawn a building, you're going to want to, run a remove citizen, right? You're going to want to delete that citizen from that fire pit. and you don't necessarily want to have to duplicate code. So we'll just put in a function called remove citizen, and I'm just going to pass in a 1, and then I'll come down here and just say func remove citizen, and we'll pass in a variable called cost, and I'm going to make that an integer. And all we'll do is make it real simple. We're just going to say for I in range 0, comma, our cost, comma, 1 for our step. And then all we have to do is just reappend our fire pit. So fire pit spaces dot append. And we're going to append our occupied fire spaces 0 like that. And then all we have to do is create a temporary variable. So var temp, and we'll make that a spatial node. And we'll make that equal to our occupied fire pit space 0. And then we need to delete any child underneath that, because remember, we're removing the citizen that's been spawned. And if I remember correctly, we have our child getting created right here. So actually, this is going to be a problem. Now that I'm looking at this, I think that we're going to need to take our citizen, and instead of adding it a child of our tree, we should add it to our fire pit spaces. That way we don't have this issue. So let's just come in here and say fire pit spaces 0 dot add underscore child, and we'll just add our citizen like that. And that will actually solve that issue. And then we can remove our child. Now, we don't actually have the ability to delete children out from underneath an object, because what if there's multiple objects under that fire pit space? Now, we're going to need to actually do some additional work when we want to delete our children. And the reason why is because when you delete the child of an object, if there's multiple children, then something could go wrong. You could have an additional citizen under there for some reason. And if we just delete that first instance, it will work in this specific case, but it might not work in every case. So let's create a function for that. We're going to call that function delete children, and I'll just pass in our temp object, and then I'm going to create a func for that. And I'll just pass in a node, and then we'll just say for n in node dot get underscore children like that. We could just say node dot remove underscore child. We could just pass in n, and then n dot q underscore free like that. And that will basically allow us to delete our child. And now all we have to do is just say occupied fire pit spaces dot remove, and we'll just remove 0. And then we can just say al v population minus equals 1. And there we go. And now that we have this little function here, we can just go back to our building manager, and where we're doing this, we can just say game manager dot remove citizen, and we can pass in our population cost. And there we go. Now, hopefully we have everything working, or at least mostly working, and it should go over fairly well. So let's hit play and let's see if anything's broken. So you'll see we have this. It attempted to do a target location fire pit translation. Fire pit position is null, so it's broken. Now, the reason why that is we have fire pit position. Let's take a look at our game manager here, and let's take a look at it real quick. So when we are doing our spawn, we're coming in here, we're spawning our citizen, his ready is running, and then we are attempting to set our fire pit space. So that looks like that's going to be our problem, because it's already instanced, or it's not quite instanced yet. Because it's instanced, it's running, it's ready, but this hasn't been assigned yet. So therefore, this is throwing a fit here on the ready. And that's why we're going to need an additional function called spawn object setup. And then we can just grab this guy and put him in here. We'll get rid of this, Control S, and then head over to our game manager and just say, just underneath our citizen.firepit position, citizen.spawn, and I believe we said spawn object setup, like that. And then let's try that. So we'll let that run real quick. And it died on us. Let's see. Non-existent function spawn object setup. Well, that's because I'm dumb and I did double spawn for some reason. So let's try it again. You'll see he spawned and now he's here. We have a second one. He goes here. We have a third one. Goes right here. And we have a fourth one. And kind of gets stuck, but at least he's there. So that's good news. Now, something that I don't necessarily like is if I go into my mesh instance, I can just delete this guy. I don't really need him. I feel like they're not going to this location. I think it's because we're not doing our global position. So you'll see if we go to our citizen, we're going to the translation, not the global translation. So let's just change this to .global translation and let's see if that fixes our issue. So you'll see we have our stuff. He spawns, goes here, spawns, and then spawns. And I think that works. Now let's test our woodcutter. So we click and you'll see it deletes one of our guys here. If we get a stockpile in here, it doesn't delete one of our guys. If we add in a stone cutter, well, I don't have enough resources, so I'm going to have to wait till I get enough resources to spawn one. So we'll wait for a second. I could probably spawn in a second woodcutter, to be honest. And we'll let those resources kind of flow in. But I've noticed that I'm not getting any resources, so that's a bug. So we're going to have to figure out what's going on with that. So let's take a look at that real quick. So I think I figured out what was going on. So if we head over to our resource gatherer script right here, something I noticed was we have our thing set to wood here, but if we scroll up, it actually says tree, not wood. And that's one of the big things that I struggle with using magic strings. So a magic string, as it's been told to me, is basically, hey, I have a string here that is serving as basically a delimiter, right? It's serving as a switch, kind of like down here. So because I didn't double check my magic string here and I didn't have it set to tree, it broke everything. This is where having an enum makes more sense because you can just say, hey, this is a tree. This is a, iron object or something like that. And I do wish that you could just export out an enum and have it work. But if we come up here to our current task and we export it and we make it a type task, basically, so our enum, you'll see it does a number. And a number doesn't really work. I mean, yes, technically it works in the sense that, there's 0, 1, 2, and 3, and you could do that, but it's not as nice as being able to see tree, stone, and iron. So that's one of the big struggles I have, and I'm sure there's a way around it, and I'm sure people will tell me in the comments and tell me how to do it better, but that's something that I've always struggled with Godot. Now I'm going to get rid of this export here because I don't need it, and I'm going to get rid of the typecast because it's going to get mad at me if I try to typecast it, and I think we'll leave it at that. So this should fix this issue. So if we hit play and check it out, if I bring in a woodcutter and I drop him right here, and I drop in a stockpile right here, so that way he just goes straight to the stockpile. Now I'm getting 15 wood, so that's perfect. And then I can see I have 4 guys here. So if I add in a stone cutter and another stockpile, providing that I have enough wood, which it costs 15 wood, so I don't, so I'll have to wait. There we go. And you'll see that our guys are going to get their resources. And I could say, oh, I want additional people. So let me come into my living, click on house, and let me spawn a house as soon as I have enough resources. There we go. You'll see my population has gone up. And you'll see we now have 2 additional guys as well. So now we have our 4 guys that we would expect. So great. Everything's kind of falling together. Everything's actually starting to work, which is awesome. So next, let's fix something that I'm not a huge fan of. I can't unselect this guy and I can't delete objects. So right now we can just build stuff, but we really can't delete anything. And we also have an object like a building attached to us, right? But we can't disconnect it, right? It's still just, it's stuck to us. We can't just let it go. So let's fix letting go of an object. So let's go to our project settings, and let's just make it so that the right mouse button down will do that. So right mouse button down, and we'll come in here. We will make it a mouse button, and we will make it the right mouse button. We're going to add that, and then we'll go over to our build manager where we're handling our left mouse button down. And let's just come in here and say if input dot is action just released, right mouse button down, then we're going to let go of our object, right? We're going to make it despawn and go away. So to do that, all we have to do is just grab current spawnable dot queue free, and then current spawnable is equal to null. And that will set it to null and get rid of our spawning capability. We also want to change our game manager dot current state equal to game manager dot state dot playing. Now, what this does is we're saying, hey, let's get rid of our currently selected object. Let's set it to null so that way none of our code that requires that will run. And then let's set our game manager state to play so that way we are not currently building. Because if we continue to build and then you click, you're going to get a gigantic crash on Godot. And that should pretty much do it. So now if we click play and we click on woodcutters and we right click, it deletes it. Simple enough. Now there is some things that we're going to need to look at. First, this if able to build and can afford. Let's put this back 1 because we don't really care if we can afford it, right? It doesn't matter to us. And that should work. So if we hit play, now I can click on my stockpile, right click, and it just goes away immediately. And there we go. Awesome. So now we need to be able to demolish stuff and destroy them. So demolishing is really easy. All we need to do is create a button to set our state to demolish, right? To destroy an object. And if I remember correctly, our game manager has a state for that, destroying. So it should be pretty simple. So we'll go into our 2D, we'll go back to our test scene, and we're going to add a button down here on the right side. A lot of games do that where they have it on the bottom right or somewhere on the UI. So we'll do that for ours. So we'll come here, we'll right click, add in a child node and add in a button. And we will click on layout and we're going to anchor it to the bottom right, which anchored it to the wrong spot. So we'll drag our button up to our control node and then click on our button and then anchor it to the bottom right. We'll focus in on it with F and we will make it about so big, and we will hit D for destroy because I can't fit destroy and normally it's just an icon anyway. So I think D will work. We'll click on our button. We'll rename it as destroy mode and we will click on signal button down. We're going to click on our control node, connect it, and we'll just go game manager dot state current state is equal to game manager dot state dot destroying, and we will go from there. So once we have our game manager set to state destroying, we can go back into our build manager, and where we have if game manager current state is building, we can just come in here and just add an if statement. If game manager dot current state is equal to game manager dot state dot destroying, then we know that we can destroy stuff. So now we just can hijack our click button to say, yep, we can now destroy buildings. And that should be pretty simple. So if we come over here, we could just say if input dot is action just released, left mouse button down, and then we can go ahead and just shoot a raycast from our camera and hit an object. Now we've already kind of done this before. We actually did this up here, right here. So we can basically just grab this bit of code here, these first 3 blocks, and we can come down here and just paste it. And that's going to save us some trouble. Now, I am truly running out of space in here, so let's see if I can make this a little bit bigger here. There we go. And you'll see that we have camera, get viewport, get camera, which is fine. We have our from and our to. And our from is our get viewport mouse position, and our to is projecting ray normal get viewport dot get mouse position. So we're ray casting from our mouse down to the ground, right? Now we need to go and get our space state. So we'll say var space underscore state is equal to get world dot direct space state. And then we can just raycast. So we'll say var result is equal to space state dot intersect ray from comma to comma, and we're going to exclude ourself. And that's how we can do a raycast inside of code. We just basically say, hey, intersect ray, where we want to raycast from, where we want to raycast to, and then if we want to exclude any objects. In our case, we want to exclude ourselves. Now we're going to need to determine if whatever comes back is a building object. Now, if we look at our building objects, we come up to it. So if we come to our granary, let's say we click on it, we have a building group, and that should be true for every object. We look at a house, we look at an orchard, select it, you'll see it has a building group. So really all we have to do, which saves us a lot of trouble, in our building manager, we can just check if result dot collider dot is underscore in underscore group quote building, then we can just say result dot collider dot queue free to delete that object. So now if we just hit play, and we spawn in a woodcutter once we get enough population. We spawn in a woodcutter, we hit D, and we click, it deletes it. But you'll notice, A, this guy's still here. B, we never got rid of our guy here. He never came back. And C, we have an object floating here, and it's just kind of a mess, right? So what can we do to help solve that? You'll see that we have our current object, click. I can right click and then click D, right? And then click, and that'll delete it, which technically works, but it's still kind of broken. So we need to do a lot more in here for this to work, right? We can't just say, yeah, queue free this, and it's gone, right? Because we need to actually bring our stuff back from the dead. So what can we do? Well, the first thing we can do is, instead of just queuing free, inside of our building object, we should have a despawn function. So I'm going to create one here called func run despawn. And what it will do is it's going to run through all of our stuff. So it's going to say, hey, I'm going to destroy this object. So I'm going to queue free. I'm also going to queue free my actor that I spawned, which I don't actually have a reference to, so that's going to be a problem. And I need to go in and release that one population person back into the population pool. And we can actually make it so that it has to be respawned. So that way it keeps a kind of like a risk reward system. You can't just spawn a bunch of buildings, then delete a bunch of buildings, and then have it say, okay, well, now you have a bunch of population that's available to you. Instead, we can kind of mitigate that by just saying, nope, this guy got destroyed with the building, or not if that's what you want to do. So first, we need to get a reference to our actor. So we'll just say var current actor, and we can come in here and just say on despawn current actor dot q_free if the current actor exists. So if spawn actor, then we know that the actor was spawned, so we're going to queue free him. Next, we're going to check if our object cost people. So I believe we had it as population cost. So if population, actually, we could probably just say game manager dot population minus equals our population cost. We also need to be queue freed ourselves, so queue free. And I'm trying to think if there's anything else we need. We got rid of our population. Oh, if we increased our population cap, we need to decrease it by that much. So if increase pop cap, then game manager dot population is equal to minus equals increase cap amount, and that should do that. Now we're going to need to do a check in here, because if our population is higher than what we have offer, we're going to want to take a happiness hit. So that's something that we'll have to code in, but I think this will do it. So we'll do our run despawn. Let's head over to our build manager, and instead of doing just queue free, we'll just come in here and paste run despawn. And when we do our spawn, we need to keep track of our current actor, because our current actor is going to be null. So when we do our spawn and we spawn our actor, we'll say current actor is equal to actor, and that will set that up. And then we can just hit play. And if we spawn a woodcutter, as soon as we have population, there we go. So first thing I'm noting is our population says 3 of 4. I think that's fine. If we go into deletion mode and we click, that trashes that. Is my actor gone? It looks like it, and we gained our population guy back. Awesome. So it looks like it's working. So that's good news. So now once we have this, I think we're getting there. I think we're almost there. So we have our spawn point. We have our global stuff. We're increasing our population. We got our despawn going. Let's fix a small bug that we have where we do not despawn our object if we're housing an object. So you can see that when we go into game manager state destroying, we didn't actually get rid of our current spawnable because we're not running this bit of guy here. So what we'll need to do is we'll need to check for that. So we'll just say if is instance valid current spawnable, and if the instance is valid, then just queue free and just make sure it's null. And I think that should work. So now if we come in here and I click on my woodcutter and then I click on my D, you'll see that it's now gone. And that solves that problem. So now at this point, I think we're good to start on our happiness system. And we're starting to actually get a fully robust game going here. So this is kind of exciting. So to do a happiness system, it actually is going to be pretty simple. All we're going to do is we'll come into our game manager here, and we already have our happiness set right here. So the beauty of all of this is that it's going to be pretty simple. Now, we need food to determine if our people are happy. So we're going to need to build some kind of food eating system, which means we need some food production as well. So that's something that we're going to have to keep in mind and put in the back of our, of our plan here that we're going to have to build this. So if we come down here, you already see how we have happiness is less than 0. So we have our happiness system already adding and subtracting people. So how do we actually start reducing our food? Well, the easiest way is if we just come in here and just say, if food bool, then food bool is equal to false, and then we'll just create a timer. And we'll just set that timer to 6.0, and we will subscribe to that timeout. Now, I know that there are some ways that we can do this that's probably better, and we'll go over that when we start optimizing and things like that. But if we just do food minus equals population, if food is less than 0, then we know that food is equal to 0. And from here, we can make all of our people mad. We'll just say food bool is equal to true. So that way we can continue through our next iteration of this. And I'm going to create a food boolean up here. So var food bool, which will be equal to true, like that. And then we can just come down here and start building out all of our stuff. So first, part of happiness is taxes. And I know you're thinking, what do you mean? You know, taxes and happiness have nothing to do with each other. But in this game, it does, right? Because we have gold in our design here under our test scene. We actually have a gold value right here. That means that we have to have a market, right? Which means that we need to tie our happiness with our taxation, and we need to tie our ability to how much we're being taxed. So if we head back to our script and we go to our building game manager, we can see that there is a food boolean, right? And just under our food boolean, we'll just type gold plus equals gold multiplied by, and we have to come up with some kind of tax rate, right? So we could just come in here and say var tax rate, and we'll just set that to a value. So we'll just set that to something like 0.02f. And I keep forgetting this isn't C#, so we'll set this to 0.02, and we'll make it equal to that type as well. We'll scroll down here and just say tax rate. And the reason why I'm setting it like this is because in the future, we're going to have an economy tab, and that tab is going to allow us to say, hey, you know, let's increase their taxes or reduce their taxes to make them happier or to make them less happy. So we'll hit enter and we'll say var happiness value is equal to 0. We'll default that to 0 at first. And then we'll say if food is greater than 0, then we know that they have food. So therefore they're going to be happy. So happiness value plus equals 1. Else, happiness value minus equals 10. That means that food is extremely important to making sure your people are happy. And then we can also check if tax rate is greater than 0. And if it is, then we know that their happiness is going to take a hit. So we can say happiness value minus equals round, and we'll round our tax rate divided by 0.02. So what that should do is if their tax rate is 0.02, then we know that it's going to be 1, because 0.02 divided by 0.02 is 1. So therefore their happiness value will be minus 1. And if they have food, it'll be plus 1. So then that means that they'll have a 0 gain in happiness or loss in happiness. And then we can just set our happiness value. So happiness plus equals happiness value. And then we'll do some constraint checking. So if happiness is greater than or equal to 2, then happiness is equal to 2, because I don't want to go too high up there. And you guys can set this to whatever you want, but I wanted to make sure that it is set up, correctly for us. Else if less than or equal to -2, then happiness is equal to -2. So basically you have a -2 to 2 happiness swing here. And the cool thing is this will allow us to dynamically control our population's happiness, right? And we also should probably check if our tax rate is less than 0. Let's say we're paying our populace to be here. We should probably have our happiness value plus equals round tax rate divided by 0.02. That way they can actually gain happiness as well. So you can purchase happiness. So if you have a world where you have 0 food, but you have a bunch of industry, you can keep your populace happy by just paying them a bunch of money. Now in this case, you'd have to pay them quite a bit of money to make them happy, but still our happiness system's supposed to be basic. We could expand it and make it into a full featured happiness system where different food makes people happier or not as happy, and we could come up with a lot of really cool stuff. And if you guys have any ideas, you can leave them in the comments below, and if we continue this little project here, then we can definitely incorporate some of those ideas. Now this should, in theory, work. So if we come to our game manager and we scroll up, we have 20 food. So if we set our food to something like 4 and we hit play, we have 4 food. Every ticket's going to tick down. And hopefully, if set up correctly, okay, so our happiness should start tanking. And now we just lost everybody. So that's not quite what we wanted. It's kind of what we wanted, but not quite. So if our people is unhappy, if happiness is less than 0, timeout, remove citizen 1. That's fine. Oh, because remove citizen 1? No, that should work. Why do I feel like I'm crazy here? Happiness is greater than 0. Let's try this and let's see what happens. So we got our 2 guys. Our food is at 2. Our food is at 0. You can see we are collecting taxes, so that's pretty cool. And now we're going to remove a guy. So it comes in, remove citizen. Oh, I think I found it. I think it's because I did equal. Let's try that and let's see if that works. So we have our first guy, and now we're out of food. And you see that they're starting to disappear slowly. Awesome. You'll see we are getting gold regardless of if our population's here or not. So let's take a look at our taxation system and let's see what we did wrong here. So if we look at our tax rate, happiness value, gold plus equals tax rate, that's definitely not gonna work because gold multiplied by tax rate would just take our gold and give us 0.2F. I don't know why I did that. So let's do population multiplied by tax rate. And that should give us what their taxes are going to be. So we're going to assume that it's going to be a straight tax rate value, and we'll round that to the nearest dollar. So round. So that way, if you have something that doesn't quite work out, it'll be okay. Now, if we calculate that, so if we say you have a population of 10 and we multiply it by 0.02, that's 0.02 gold. So we definitely don't want that. We should probably make it so that the tax rate is 2 gold, maybe, per population. So maybe we should take this, divide it by 2, come up here to our tax rate and set that to 2 as well. And I think that'll give us a more accurate estimation of what our tax rate should be. So our population is 0. Now it's 1, 2. So we got 4 gold, 3, 4. So now we're getting quite a bit of gold here. So we should get 4 gold. Okay, so now we should be getting 0 gold. We are not getting 0 gold. So that means that our population destruction section is not working properly. So we have population plus equals 1. When people are leaving, we are just removing our available population, and we're removing it from the citizen pool, but we're not removing it from our population. So let's fix that. Okay, see, so now we have 120 gold and 0 food. Sweet. So that definitely works. So if you get yourself into an economic tailspin and your population just gets decimated, it's over, and there's really not a whole lot you can do. But how can we produce food? Well, we do have ourselves a granary object and an orchard object, although the orchard object doesn't really spawn yet, but we do have an orchard object, which is cool. We have a granary. So let's set up the ability to actually create food. To do food gathering, we are going to need to actually adjust our orchard object. If you remember, we created an orchard object here. So if I open it up real quick so you guys can see it. If you remember, our orchard object looks like this. And it's basically just a box with some building with some basically small trees, okay? And these trees are underneath our spawn point and our resources, and then a bunch of mesh instances, and that's it. And if we take a look at our orchard, it costs 15. I'm going to set that to 5 for right now. And you guys, of course, can set it to whatever you want. But for testing purposes, I'm going to do 5 because it's going to make life just a touch easier for us for debugging purposes. Now, if we head over to our building code, you can see that we have all of our building code like you would expect. So everything is basically falling in pretty well. We technically could spawn our orchard if we had an orchard worker. Unfortunately, we don't, so we have to create one. But that's going to be really easy because we already basically have our code done for us, right? We have our resource gathering script right here. We can basically just duplicate our woodcutter and then just put a resource gatherer.gd on it, right? And that'll solve our problem. Except for it doesn't quite solve our problem because our code is going to be different. And it's going to be different enough for this code to basically be its own script. So what I'm going to do is I'm going to copy all this code. So select all of this code, copy it. I'm going to right click on my woodcutter here, and I'm going to duplicate it. And then I'm going to call it orchard worker, like that. I'm going to double click my orchard worker. I'm going to rename it orchard worker. And then I'm going to right click, detach this script, right click, attach a script, and call it food gatherer, like that. And then I'm going to Control A and Control V. And the reason why I'm doing it this way is because this script is going to be different enough for us to actually make a new script. And we're going to be making quite a bit of changes. The first one we're going to make is instead of gathering resources, we're going to say gathering food, which means we have to come down here and change this to gathering food as well. Now, when we look at our orchard, we have all of our trees right here underneath a resources. So we need to make sure that we actually use these resources. So if we go to our orchard worker, we're going to need to add in a variable that houses all the different places we're going to walk to, right? We need to walk to each tree to pull down the apples so we can get food. So we'll say var food producers, and we'll just make that a type array. So that way it's array of objects. And we also need to know which tree we are currently at. So we're going to say var food index, and we'll make that a type int. Now, what this is going to do is our orchard worker is going to walk to this tree. They're going to wait for 2 seconds. They're going to walk to this tree. They're going to wait for 2 seconds. They'll walk to this tree and then this tree and so on and so forth. So how we can do that is we first need to know what our index is. So when we get done with one tree, we can increment our index and then move on to the next one. We also need to know when we have all of our indexes done. And we also need to set up our food producers to actually work. So to get access to all of our food producers, we can just pull back our hut, which is right here. And remember, our hut is the object that spawned us, the actual orchard that spawned us, the orchard object, or really it could be the woodcutter object or the stonecutter object, things like that. So it can really be any object that spawns us, but our hut is whatever our home base is. So we could just come in here and say func underscore ready, and then we could just say food producers dot is equal to hut dot get underscore node quote resources dot get underscore children. So what is that going to do? Well, if we look at our orchard, we have our spawn point, which is what we pass in to our hut. And actually, it's not what we spawn in. We actually pass in our global translation, and we don't necessarily want that. So maybe we should get rid of that and do that instead. I think that'll probably fix that problem, but that's fine. If we go back to our orchard worker, we're gathering our resources, and then we are getting the children right here, and we're fetching these guys back. And once we have that, then we know that those are our food producers. So now we have an array of those objects, if that makes sense. Now, if we look at our orchard code real quick, this needs to move up one to here, because something that I should have mentioned earlier is as soon as this guy goes into the scene, as soon as we spawn our actor, when this code runs, your ready function runs. So if this is below this, then we're going to get a object reference not set to an instance of an object error or a null reference error, and it's going to break our code. So we're going to need to make sure we move this guy up and flip it. Now, if we go back to our orchard worker, you can see we have our food producers is equal to hut.get children, and that should work. So now we have a list of our food producers. So now all we really need to do is just say, hey, we're getting our food. We are waiting for 2 seconds to get our food. We now have our food from our tree, and we don't necessarily want to deliver our food immediately, right? We're done with one tree, not with all the trees. So that means that we need to actually search for our next index. So what I'm going to do is I'm going to set this to searching like that. And then we're going to come down to var searching, and I'm going to completely get rid of all of these guys here because they're not necessary anymore. And we're going to set our target location equal to our food producers. We're going to pass in our index like that. And that's pretty much all we need to do right here. So this is just going to set our next index that we're going to move to. Now, if we're going to searching mode and we're going to our food index, we can't just go to the same index every single time. We need to increment it somewhere. So when we get our food, we're done with that food, we should increment our index. So we should say food index plus equals 1, and that will increment our index. But we might not want to increment our index if it's our last food production, right? So we should come in here and check for that. If our food index is greater than our food producers dot size, then we can basically just set our current task equal to task dot delivering, and that will kick us out of this little searching loop that we're stuck in, if that makes sense. Now, something I'm thinking about is we need to set our food index back to 0. So we could just go food index is equal to 0. Because we know that we are above what our food production size is, so we must be done with checking all of our apples. and our food index is now 0. Now, if we head down to our delivering task here, we are getting nodes in group and we're getting our stockpile. Now we need to get our granary, but the problem is our stockpile is not where we get food. A granary is. So if we take a look at our granary, how can we fetch back our granaries? Well, much like we fetch back our stockpiles, we can just put them in a group and then fetch them, right? So we can click on this guy, go to our nodes, come in here and type granary like that. And then we could just copy this guy. We can come over to our orchard worker, double click and paste. And there we go. And then we could just change this to granaries. So lowercase g, granary with an S. Copy, paste, paste, paste. Because we want to make sure that our code makes sense to us. And it says nearest stockpile object. So nearest granary object like that. Paste that, paste that, paste that there. And that should do it. So for I in that, it's going to go fetch the closest granary it can. It's going to set the target location to the granary.getNode spawn point. And that should work. And then it's going to get the current task is equal to task.walking. And then we are going to walk to our location. Now, this section here is definitely going to need to change because we don't need any of this, thankfully. None of this is useful to us anymore down here because we completely ripped all that out. So we could just get rid of that and we could just assign our game manager stuff. So game manager.food is plus equals held resource amount. And then we could just set our held resource amount equal to 0. And that'll basically do that. Now we have one small bug. Current task is equal to task.getResources. We don't have getting resources anymore. We have getting food. So we'll copy that. We'll come down here. We'll find wherever that is. We'll paste it in and we will control S. And hopefully we can definitely get rid of this. We don't need it. But hopefully that will be it. I think we're good. So let's hit Control S. Let's go back to our orchard here and make sure we save our granary as well. And let's go back to our orchard. Let's go up to our orchard object and then let's come down to our orchard worker and drag it into our actor. Now, if we hit play, providing we did everything correctly, we should be able to come in here, go to food, go to granary, drop in a granary, go to orchard, and drop in an orchard. So we have an error, invalid type in function set location on base nav agent cannot convert argument 1 object to vector 3. And that's because our food producers.food index dot global underscore translation. So that's the reason why we're getting that error, is because we're trying to pass back an object, not a vector 3. And a vector 3 is a position, and object is an object. So that was the reason. So let's refresh this. Let's try it again. So we'll come to our food, drop in a granary, and then let's drop in an orchard, and let's watch him do his thing. So it gets 1, gets 2, gets 3. You can see our code seems to be working. Let's see if we can actually get some resources out of this. Oh no, we have a crash. So that's not good. Invalid get index 6 on base array. So the reason why we're getting this error is our food index says we have 6 objects. We actually only have 5. So this is not going to work. So why did this issue show up? Well, here's the reason. We have our food producers.size. Our food producer.size here is 6. And our food index is, so that's kind of weird, right? So our food index is not greater than our producing size. So it didn't catch it. As a matter of fact, so how can we fix that? Well, what we can do is we could just -1 and that will solve our problem. So now we could just hit play, come in here, go to our food, drop in our granary, and then drop in our orchard. And I'm going to speed this up so we can see this thing run real quick. And you will see that he walked over there and he did what we expected, but we did not get any food and our index is not correct. So let's take a look at a few of these things. So first things first, we are skipping our first tree. So let's take a look at our stuff. So let's come in here and let's change this to GameManager.food, not lowercase food. And then let's just set our index equal to 0. And let's see if that fixes our problem. I don't know if it's going to because we have this food index plus equals 1. But that should only run once. That's going to be fine. So I think it's because we're not resetting our index properly. So let's try that and let's see what that does. I am definitely going to fast forward this for you guys because I know that this is probably slow. Also, we need to do some balancing because we're running out of food way faster than we can produce it. And the reason why is because we are not giving ourselves enough food and we need to time all of our resources up. And that's something that I'll leave you guys to do. But basically, we're going to need to balance all of this. Once again, we didn't get any food, and let's see where he heads. To the second index, so that's not ideal. Take a look at our orchard guy. Oh, he's not generating any resources, so that's part of your problem. So we'll set this to something like 4. And let's set his walk speed up to 10. That way he can move nice and quick. And let's see if we take this. Actually, I think what's going on... So I'll just move this down to wherever our moving code is. So I'll just drag this guy down here and see if that fixes our problem, because that might work. And our walking code should probably say something like if index, food index does not equal food producers dot size. I'm kind of curious if that will fix that. And then drop this in here. And pull out this reset here. I'm going to make this a greater than or equal to size like this. See if that does it. Oh, and while we're at it, we might as well change this to plus equals, not just equals, because that's probably going to break something. So we'll hit play. And let's try that. So we'll go to food. We'll drop a granary in. We will drop an orchard in. And that movement is a lot more responsive. I think 10 might be our sweet spot. So you'll see our food is going down. We're at 0. If we're lucky, we should get something like 18, I think. I'm not very good at math, so forgive me. 24. I think that makes sense. Yeah, 4. I was thinking 3. So yeah, that makes sense. So now we have this guy producing enough food. We should regain population as soon as our happiness goes back once we dig ourselves out of our hole. Now the question is how big of a hole are we actually in? Because I'm thinking that we might be in too big of a hole from our game manager. So let's actually build out a UI element for happiness. So we have our population here. So I'm going to build out an element so we have ourselves a test element. So control duplicate, and we'll just say hap and hap value. And we can just type HAP like that. And then I'm going to go in the interface manager here, come down here. We'll just copy that and paste it. And I'm going to get rid of all this nonsense. I'm going to come down here and just drag in hap value. And then come over here and say str game manager dot happiness. And let's see what's going on with our happiness. Because I got a feeling that our happiness is not very good once, even if food gets reestablished into the work queue. I think we're having a problem with our happiness staying at -2. And then not coming back up. So we're at -2. People are going to start leaving, which is fine. That's what we expect. He's going to come in, drop food off. So we have 24 food. So we're going to maintain at 0. That's why. So we're maintaining at 0 because our taxes are too high. So we may want to give ourselves a +1 benefit of the doubt here, just so that way new players don't get frustrated and it'll make things a little bit easier. But that's up to you guys. I'm going to do that for our game purpose because it's going to make things a little easier on us while we're coding. So I will just come in here and I will say where happiness value is equal to 1 by default. And then we should be able to see how this goes. So happiness is 1. I'm going to drop in a granary and I'm going to have to restart because I'm dumb and I put a stockpile first. So we'll drop in a granary and then we'll drop in an orchard. I wonder if I could fit a stockpile in here. Can I fit a stockpile in here? No, it's too expensive. That's okay. So we're at -2 happiness right here. Gonna come in, try to save the day. Our happiness is -1 with 1 tick. Our happiness is now 0. Our happiness is now 1. So now we should start gaining people. Awesome. So now food actually has become a useful thing. We actually need to make sure we have food. If we don't have food, everyone's going to starve and people are not going to want to be here. Now, our food production probably is not enough. We probably need to make our food production a little bit less aggressive, but you can see here that we actually have ourselves a food system that works and a happiness system that also works. So now let's set up something that we probably should have set up a while ago. And that is the ability to rotate our buildings because we have walls. So you can see we have this wall narrow, but a lot of good that this wall is going to do me if I can only place it like this. How am I supposed to be able to use it if I can't rotate that wall if I wanted to build a wall around my castle? So to do that, what we need to do is we need to go into our build manager right here. And we basically just need to add in a new mouse input, which in this case is going to be the middle mouse button. So let's go to project settings. And let's just add middle mouse button like that. And we'll click on this. We'll say mouse button, middle, add, and then we will come into here where we have our if input action just release right mouse button. We could just come in here and go if input dot is action just released middle mouse button, then our current spawnable dot rotation degrees plus equals 90. Vector 3 0, 90, 0. And then if we just hit play, that should work. So if we come in here and we want to put a stockpile down, we want to rotate it, we can just click the middle mouse button and bam, it rotates. Easy enough. I can't believe we forgot to do that. But at this point, we're starting to make an actual game here, which is awesome. Now, let's just set up our economy section and our market section, and I think we'll be pretty good to have a semi-decent game here. So to set up an economy tab, which is basically a place where we're going to edit our taxes, and it's a place where, you know, if we wanted to see more detailed breakdown of our people's happiness and stuff like that, we could add all of that there. Now, in our case, it's just going to handle taxes, at least for this specific stent. So to adjust the taxes, let's just go to our economy tab here. So we'll come in here like so in our tab controller. We'll find our economy tab and we can basically just right click this guy, delete this node, get rid of it, right click, add in a child node, and let's add in a control node like that. And I'm going to hide my industry panel. I'm going to turn on my economy panel. I'm going to right click, add in another child, and I'm going to add in a label like that. I'm going to duplicate that label, and I'm also going to right click and add in 2 buttons like this. So I'm going to add in a button and I'm going to duplicate it. And the label itself is just going to say taxes. And then this will have a number. So something like 2%, like that. And we'll just kind of drag this guy over like so. And we'll just grab these two buttons, drag them over like this. We'll hit a plus icon and a minus icon like that. Now we can just drag these guys up so they are kind of in line with what we have. So all we have to do is just say increase taxes and decrease taxes like that. And then we can just come in here, select one of these guys, node, signals, on button down, control node, connect, decrease taxes, button down, control node, connect. And then we can just say game manager dot tax rate plus equals 2. And if the tax wants to go down, we can just say plus equals 1 or minus equals 2. Like that. And we can set this label here to get updated. So we could just call this tax rate like that. We can come up here and just drag in this tax rate here. This little label dot text is equal to str game manager dot tax rate. And then we'll also append a percentage symbol on top of it like that. And that's basically all we have to do. So we can just hit play. And you can see if we click on economy, we can increase taxes. We can decrease taxes. So you can see if we have 0, you'll see that we are not gaining any money from these guys at all, even though we're still losing people. We can also go with minus 4% like that, and we could try to dig ourselves out of a hole. But once we don't have any happiness, let me see if that actually works. I don't know if we can dig ourselves out of holes or not. Let's take a look at this code real quick. I think what's going on is this might be backwards. Tax rate greater than 0, then minus happy value. We'll do that. Hit play. Let's take a look at this real quick. So if we go to economy and we start paying our people 8%, happiness value is -2. Our tax rate is -8. I think we actually want to do minus. Let's take a look. So economy, go like this. Happiness value of 6. So there you go. And that's how you can definitely make a good impact. So the happiness value is 6. Everyone's super happy that we're paying them money to stay. So that's kind of how you can work your way around the food requirement. Now, I did also move my area 2D by accident, it looks like. So let me just grab that guy and drag him back across. There we go. And let's go ahead and build the final section of our project. Because at this point, I think we're at like 5 hours or so of this tutorial. So I don't really want to make this tutorial way too long. So let's build out our market and then we will go over what we learned. So to create our marketplace, it's going to be pretty simple. We're basically just going to come into our market right here, and I'm going to hide the economy tab, and I'll just open up the market tab. And you can see we have a button for woodcutters. Now, we don't need that button for woodcutters because obviously we're not going to be doing any spawning of woodcutters. We are only going to be interacting with our marketplace. So it should be pretty simple. We're basically just going to have a buy and sell panel, and that should be pretty simple. So we'll just come in, delete this guy, right click, add in a child node, and let's add in a V box container. I'm going to right click that, and I'm going to add in a child node. So I'm going to add an H box container like that. And I'm just going to add in another child node, and I'm going to add in a label like that. I'm going to duplicate that label. I'm going to right click, add in a child node, and add in a button like that. And I'm going to duplicate that button. Now I'm going to select my 2 labels. So I'm going to come down here and I'm going to set this one to food : space like that. And then I'm going to come in here and I'm just going to say something like 100 or 1,000. Then I'll come into my button and I'll put a sell. And for button 2, I will say buy like that. And then the cool thing is we can just duplicate this guy and then we can duplicate this guy. And now we have all of our different resources. So we have our food, which we'll label as food label, and then food value like that. And then we can come down here and just go iron label and then iron value. I should probably get rid of the space just because it makes it easier with Godot. And then we can come down here and just do stone label and stone value. Also, I should come into my iron label and just say iron colon space and stone colon space. Then I'll come down to this one and do wood label and wood value like that. And then we can select our wood label and just set this to wood like that. And we should be good to go. Now we're going to have these buttons here. So we're going to need to set these buttons. So sell food, buy food, sell iron, buy iron, sell stone, buy stone, sell wood, buy wood, like that. And then we'll just hook all of these guys up to our market. Now, I could hook it up to my interface controller, but in my opinion, I want to separate my market from my interface controller. That way I can just have a smaller code base. I don't want one gigantic function. So I'll just come down here and go to my sell food, click on my node and go button down, come down here to my market. So I'm going to right click my market and I'm going to attach a script and I'm going to say market.gd. I'm going to click on my sell food, button down, scroll down to market, double click, buy food, button down, market right here, sell iron like this, market, buy iron, market like that, sell stone, buy stone, sell wood, and buy wood. And there we go. There's all of our stuff hooked up, or at least it was supposed to be, but it didn't want to. So we'll do this and we'll do stone again. Oh, come on, Godot. There we go. And that should have everything hooked up. Now, the fun part about this is obviously we're going to have to balance the heck out of this, and we don't have the time to do that, especially since, like I said, we're about 5 hours into this tutorial. So what I'll do is I'll just give you guys the tools to balance it yourself. So when we do our market, all we're going to do is we are going to buy something, right? So let's say we want to buy some iron, okay? We can come in here and just say if GameManager.gold is greater than our cost, which let's say iron is 40 to purchase it, okay? Then we will go ahead and say GameManager.gold minus equals our cost, which would be 40. And then we will say GameManager.iron plus equals however the amount that we're purchasing. So let's just say 5. And that is basically how we're going to buy our stuff. And then to sell, we're basically going to do the same thing. So if our item GameManager.iron is greater than the amount that we want to sell, so let's say 5, then our GameManager.iron minus equals the amount that we're selling, which is 5, and then GameManager.gold plus equals however amount that we get out of it. Now, we don't want to give them more than what they can buy it for, and we don't want to give them a good deal. When you sell something, the merchant wants to make a bunch of profit. So let's do something like 25 or 30. That way, if you bought iron and then you say, "Oh man, I have to sell this," you're losing 10 gold on the transaction. So that way, the market still stays in flow. The merchant still makes money, and that's always the goal. Now we could basically just duplicate this code for each one of these guys. Or instead of duplicating our code, because duplicating code is bad, we can take this and just make it into an adapter function, or just abstract it out to a function. And what I mean by that is if we copy this guy and we come up here and we just create a function called buy, we pass in a cost and we'll make that a type int. Then we pass in an amount and we make that a type int. And then we pass in the item that we are purchasing and we say, hey, we're going to return an int. Then we can basically just paste this and just say, okay, if we're purchasing something, then we know that if GameManager.gold is greater than the amount, the cost, then we can take our gold and we can minus equals the cost, and then we can just return our item plus amount, like that. Else, we can just return our item because we didn't make the transaction. We did not have enough money. And then we can just come in here and just go buy, and we can pass in our cost, which in our case, if I remember correctly, our cost was 40, comma, we got 5 out of it, and it was GameManager.iron. And since we're returning an integer, we can just say GameManager.iron plus or is equal to our purchase. Now we could just do the same thing about our cells. So func cell, we could pass in our amount, make that an integer. We can pass in our money, make that an integer. We could pass in our item, and then we can just return an int like that. And then we could basically just say if item is greater than amount, then GameManager.gold plus equals money, return our item minus amount, and then return item. Basically the same thing that we are doing right here. And then we basically could just take this guy and go GameManager.iron is equal to sell the amount, which is 5, the amount for how much money, 30, and what the object is, GameManager.iron. And that's it. And that's going to make things a lot simpler. Now we do need to re-add our food by food because for some reason it missed that. So we'll connect that in. And when we sell our food, we basically could just say GameManager.food equals buy, or in our case, sell. How much food are we selling? Well, we're selling 5 food. How much do we get for it? 15 gold, let's say. And then we could just pass in our GameManager.food. And I need to capitalize iron. For stone, it'll be pretty simple as well. It's basically just copying and pasting code at this point. GameManager and I can pass in these little parentheses. Game Manager, capital M. And then sell wood, GameManager.wood is equal to sell. And for us to sell our wood, we'll get 5, 5 because it's a very common item. GameManager.wood. And there we go. To purchase wood, we're going to want to cost more. So GameManager.wood is equal to buy, and we need to make it more expensive. So 10, comma 5, comma game manager dot wood. Purchasing stone, same thing. So game manager dot stone equals buy 20, comma 5, comma game manager dot stone. Like that. And then finally buy food. So game manager dot food equals buy. And to purchase food, food's a pretty expensive commodity. So we're going to say 25 gold and you will get 5 food out of it. And game manager dot food. And there we go. Now we just need to make sure that we keep track of how much food we actually have. So let's grab these guys and then basically just drop in links to our market text. So we can come in here and we can basically just say, all right, food value right here dot text is equal to str game manager dot food, like that. And then we can come in here, grab our stone value dot text is equal to str game manager dot stone. And our wood value, same thing, dot text equals str game manager dot wood. And I think we got one more that I missed right here, iron. So we can drag our iron value in like that, dot text str game manager dot iron, and we should be good to go. So now we can hit play and we can click on market and we can buy food. You'll see that our gold went down, but now we have more food. We can sell stone. Our stone went down. We can buy stone. We can sell wood. We can buy wood. We can sell food. We can buy iron and we can sell iron. Well, we really can't sell iron because we can't. Oh, actually, we just can't sell iron. So let's take a look at our iron sell button real quick and see what's going on here. So 530. That's because it's greater than the amount, not greater than or equal to. So that's my fault. We should probably do the same thing, greater than or equal to cost. That way you can purchase it if you just have the money. So we'll go back to market. And if we go sell, 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 buy, 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 and that will work. Awesome. Okay, so at this point, I think we're good. We're probably 3 or 4 or 5 hours into this, to be honest with you. I'm not really sure. And we have ourselves a very basic RTS-esque base building framework. And with this framework, we have the ability to generate our resources. We have the ability to create food. We have the ability to handle our populace's happiness, and we can tax them and get money in return, which in the future we could use to fund maybe a military or something like that, or maybe research if we wanted to expand this. We also set up the ability for populations to come and go based off of their happiness, and we built a small market. So that is all I have for you guys today. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I am here to make content for you guys. This video was not a viewer suggested video. However, if you guys have any suggestions, please throw them in the comments below, either about this video or just all new ideas in general. I want to make good content for you guys. So please let me know where I can move this channel. Let me know what you guys want to see. And hey, if you guys have any questions or comments about this video or any of my previous videos, hit me up either in the comments below or jump on my Discord. The link is in the description and anybody there will help you. They're all a bunch of really cool guys. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.